All right, I think we're going to get started this morning. This session is all about beach restoration, and we have several speakers that are going to give great examples and great stories about successful beach restorations in their area. Our first speaker this morning is Sherry Faust from the St. Clair County Health Department, and she's going to be talking about a successful beach restoration in an area of concerns. Great.
Good morning. I'm lucky enough to kick off the last day here. Oops. I'm Sherry. I work for St. Clair County Health Department. We're downstate of here in the thumb of Michigan. I'm going to be talking about our problem child beach today. It's Chrysler Beach. And the goal of our project that we did, we were trying to reduce E. coli at some of our beaches, at all of our beaches, but mostly we were focusing on our beach that's in our St. Clair River area of concern. And with the anticipated outcome that we would be able to remove and restore our beach closing impairment for our area of concern. Our health department, we oversee our county's beach monitoring program. We also oversee and run our county's NPDES stormwater permit, and we do watershed planning for the county. So we have our hands in a lot of water quality pots at the same time. Here's where we are to give you some perspective. We are on the east side of the state, like I said, in the thumb. We're at the southern tip of Lake Huron as it flows into the St. Clair River and into the northern edge of Lake St. Clair. St. Clair River is what I'm going to be focusing on today, and that's what separates us from Canada. St. Clair River is a unique, significant area of concern in the Great Lakes because we are only one of 5 binational areas of concern. There's 43 areas of concern throughout the Great Lakes Basin. 12 of those are in Michigan. And like I said, there's 5 binational ones, and we're one of those. The St. Clair River is a 40-mile long river, and like I said, it shares the border with Canada. We were designated an area of concern in 1987, and like all areas of concern, they suffer from decades of environmental contamination from industrial sources of pollution, municipal sources of pollution, and our river was too polluted to fully benefit the human and natural communities that depend on it. Our U.S. side of the river, we had 10 of 14 beneficial use impairments. The Canadian side of the river had 12 of 14 beneficial use impairments, and the beach closing impairment is one of ours. Just at a glance of our county, we have 20 public beaches in our county. 15 of those are Great Lakes beaches. 5 of them are inland beaches. We're currently monitoring 8 of those. One of our beaches is Chrysler Beach. That's the problem child I'm focusing on today. It's in our St. Clair River area of concern, which I've highlighted there in yellow to give you some perspective of the river. We do have one other beach that's in our St. Clair River area of concern. It's towards the south. It's Marine City Beach. And I just wanted to point that out to you because I'll mention it in a little bit later. We've been doing our beach monitoring program for 20 years now. And here's the beach I'm talking about today. So this is showing the E. coli monitoring data for Chrysler Beach. And this beach became a focus of our program in 2009 when it was closed for a record 29 consecutive days. We closed it first about the end of July, and it never opened for the rest of the season. And this is the first time this has ever happened in our 20-year history in any of our 20 beaches. We didn't know what was going on. We didn't know what to do. We contacted the state for help because we just were not sure what to do. This is one of the reasons why we have a beach closing impairment in our area of concern, and this was holding up progress. So we had to dig our heels in. and figure out what was going on. We had some point source problems, we had some non-point source problems, but our three top challenges were wildlife issues, combined sewer overflows and illicit discharges, and stormwater runoff. So 2009 is when we had the 29 consecutive day closure. 2010, the health department received GLRI funding to help us understand and improve water quality at all of our beaches, but really we were focusing on Chrysler Beach. We wanted to study the beach more in depth. We increased our monitoring frequency. And the city of Marysville, where the beach is located, was also a really important partner, really great to work with. So these combined efforts here resulted in us identifying three illicit discharges, or three illicit connections to the municipal storm drain system. We were able to reduce the Canada geese population at Chrysler Beach, and then Marysville was also able to receive some GLRI funding to do some work at the beach. We needed some goose best management practices staff. The health department began working closely with the city of Marysville to address these problems, and you can see in the background there are some apartments, I think they are condos, where the residents love to feed the geese. So the geese were so happy. The geese were loving life. To start, the city purchased 4 coyote decoys, installed those at the beach, and they were moving those on a weekly basis, but there was challenges. It was a pain to move those, and some got stolen. And the residents also weren't happy with being told not to feed the geese. They really loved doing that. So we had the coyote decoys for 2 years. We also hired a goose roundup service, and we rounded up 167 geese over 2 years. And my colleague Chris from Monroe County Health Department is not here, so I can mention that we moved all the geese to his county, a couple counties south, so they became Monroe County's problem, but they were no longer our problem. So more geese, birds hanging out at the beach. This is showing a before picture of the turf, mowed turf, right to the water's edge. And now here are some BMPs that were used. There was tall goose deterrent grasses that were planted, and you can see again the condos there in the background. And the residents first complained about the tall grasses. They did not like those, but now there's a lot less poop on the beach. This is looking south. Again, looking south, no geese. So the grass divides the beach from the mowed turf. And there are a lot fewer geese, if any. I haven't noticed any there, so compared to past years, it has greatly improved. Second problem was addressing combined sewer overflows in the St. Clair River. This map is from 1991, showing all of the combined sewer overflows that we had in the St. Clair River. The yellow line is highlighting the St. Clair River. So on the left side we have Michigan, on the right side we have Ontario. We have 53 combined sewer overflows discharging into the St. Clair River from 4 plants. The U.S. side had 49 of those CSOs. Canadian side had 4 of those. So in Marysville, there were 3 CSOs. To the large city north of us, Port Huron, there was 21 CSOs. So full separation of CSOs was accomplished in about the mid-90s. But despite these major system updates, Marysville was still experiencing sanitary sewer overflows. So just a few years ago, they addressed the issues of SSOs in Marysville with a 3-step plan. They rehabbed over 100 sewer structures throughout their city. They did upgrades to their wastewater treatment plant, and they designed storage for their sanitary sewer overflows. So this is a 1991 case with 53 CSOs, and today we have 1 CSO left in the St. Clair River, and that's in Port Huron, north of us. We've done wet weather monitoring since all of this has been done, and no CSOs have occurred. Everything's been within limits. So as a result of the GLRI funding that the health department got and Marysville got, and with the help of ECT, we were able to do a little bit more investigative work at Chrysler Beach. So ECT helped us get some samples with a storm drain that discharged just north of Chrysler Beach at outlet A there. The E. coli concentrations were high enough that we could suspect sewage as a potential source. So Marysville, they were great. They really took ownership of this and really went at this. They conducted dye testing, which revealed 3 illicit connections discharging into outlet A. 2 years ago, they finished construction projects to remove these 3 illicit connections. And the DEQ then asked us, the health department, to come in and do some wet weather sampling, and all samples were within the limit. So these illicit connection removals were successful, and this was helping to solidify our validation of removing our beach closing impairment. The last problem we had to tackle with non-point sources was stormwater. We had, this is showing before a picture of the parking lot, and the road just beyond that, just sheet flow, direct runoff right into the beach. There was erosion and washout. There was no buffer. After the solutions were to install bioswales, reduce pervious surface, and regraded the parking lot so it didn't drain right into the beach. ECT designed these improvements, included new planting beds and installation of rain gardens and trees. I'll show you a few more pictures here. So this is the exact same spot, picture, exact same position, exact same perspective, showing the buffer that was put in. This was right after the rain gardens were installed, right after a rain, showing the buffer between the parking lot and the beach. So these plants were just newly planted at that time. There was an outlet right on the beach. Example where you shouldn't put a beach, but parking lot just went right down there. And now the parking lot has been redesigned and regraded so that it flows into these rain gardens, which surround the perimeter of the parking lot. So it drains north to south now instead of east to west. And signage was installed, more of the rain gardens surrounding the parking lot. And this has really helped reduce beach closures at Chrysler Beach. Signage explaining the plantings. So this is a very successful partnership between St. Clair County, City of Marysville to get all of this done. Really a great collaborative, successful work. Education was really a big part of this also, putting up pollution prevention signage, different materials. The St. Clair County Health Department has its own Facebook page, but we've made our own Facebook page for our beaches, which has probably about 3 times the following that our health department page has. So our health department has a Facebook MV of our beach page because it's just such a hot topic, and we have such great beaches in our county. So we get a lot of followers, and we're able to do a lot of education through our Facebook page. So the icing on our water quality cake happened just a month or 2 ago when the EPA removed our beach closing beneficial use impairment. So this problem first started in 2009 with those 29 consecutive days, and for 7 years we've been working on this. Thank you. And we were able to remove it this year, so this is a significant milestone. And it's hard to believe that those days 7 years ago of moving those coyotes around and moving geese around, like, now we're here, and this is what has happened. So the St. Clair River is healthier and providing fewer beach closures. It's a shining example of how community investment and partnership can create and sustain an environmentally viable place. Thank you for allowing me to share our project. Are there any questions? Right there. Oh.
What was your removal target for that DUI? Was it tied to the amount of closures or percentage? Or?
It was tied to the amount of closures, the frequency of the closures. We looked at all of the CSO data and the discharges from wastewater treatment plants and the E. coli. That was pretty much it. Yes.
You mentioned the Facebook page is popular. What are people asking about when they go to the Facebook page? What are they looking for?
They're looking for the most recent information we're providing about the beach closures. So we get the information out right away. We do it through our hotline, we do it through press releases, and we do it through the Facebook page. So people just want to know, how are our beaches? Are they open today? Are they closed? And they ask a lot of questions on the Facebook page too about, why, or we saw this, or why did this happen, or how come you're doing that? So we can provide a lot of education that way. Yes?
You've shown those multi-sources, but intuitively or by model, which ones do you think were the most potent contributors to your closures?
Probably the wildlife. Probably the geese. That's the only thing that we could figure. We didn't know why it spiked so high in 2009 and hadn't before, if the illicit connections were there. Why wasn't that a problem before? So we just didn't know what had happened or what was going on. But geese were a huge problem, and the CSOs were gradually being taken care of. And then the illicit connections that the city fixed were huge also. Yes?
Another alternative way to get rid of the geese in my cat, we use shotguns.
That was discussed at length, and many people were willing to volunteer to do that, but we were not allowed.
Every Wednesday morning at 7 a.m.
Yeah, we couldn't do that. We wanted to. Thanks.
Thank you, Sherry. Our next speakers, we actually have two speakers for this next talk. They're from AECOM, Carol Kim and William Weaver. They're talking about a Montrose Beach sustainable proposal to improve beach water quality and public access. I think Carol's going to start it up.
Okay. Good morning, everyone. So my name's Carol. I'm actually from the Chicago Park District, and Bill here is from AECOM. And so today we're going to be talking about the sustainable plan to improve beach water quality and public access at Montrose Beach. So I don't know if any of you guys have been to Chicago. We manage 26 beaches. One of them are inland beaches, but the rest are all along the lakefront. And so this is also our problem child. Let's see. Oh, also Kathy Brettenbach will not be here today. She has been a big part of helping us develop the sustainable plan, and so she is here in spirit. So the reason why we wanted to study Montrose Beach was because we're having a lot of problems with water quality exceedances. So you can see right here, Montrose Lake. It's what the public refers to it as. It's because it is actually 2 to 3 feet deep at its worst points. And so when you actually have to walk through the lake to get to the beach. And so a lot of people are having a hard time actually accessing the beach. And we're not sure whether the beach is causing all of these high exceedances. So we were thinking that it's probably playing a big role, because you'll see a lot of, number one, dirty diapers. You'll also see a lot of wildlife hanging out around there, and then a lot of broken glass and just a lot of decomposition. Things just sit there. It starts to smell. You don't know what it's from, and we believe when there's high tide, then it'll just kind of wash all that back into the water, and by the time we're testing it, we're testing a lot of the water that came from Montrose Lake. Oh, and also other people think that a lot of our water exceedances come from the Dog Beach, which is up north, but a lot of the times the Dog Beach actually has lower exceedances, so that is really interesting, and we think that's because they scare away the geese, and humans, we feed them, so it's different. Also, I mentioned public access, so it's about 2 to 3 feet deep when you walk through, and it was a big operational issue. So we groom the beaches every day. The groomers cannot get through that depth of water because the machine will get stuck. And so we will hand pick as much as we can, but because it gets so gunky, you can't see in it. And then so because we can't groom it, we can't have events there. So the amount of events go down, our revenue goes down, and then the amount of people that are happy also go down, and the amount of mean comments and voicemails that we get go up. And so we wanted to kind of avoid that. And so to kind of like paint a picture of how popular this beach is, it was the #1 visited beach in Chicago this year. We had around 2.8 million people visit this beach just for the summer. And so that means what we have going on, We have concessions, so kayak, paddle boat, canoes. We have 2 natural areas near there, south of the beach, and so we have active stewardship going on there. We have volleyball teams play. We have a boat harbor south. We also have yoga groups, summer camps, and obviously the dog beach that's north of it. And so just to give you an idea of how many days out of the summer this beach has advisories, not closures, but advisories. You'll see on average it's about 19 days out of the entire summer. So that's like about half a month or a little bit more than half a month. And so this becomes a problem because we get a lot of complaints, unhappy visitors, and also it is hurting our revenue. And so how we currently manage it, we will groom the beach daily before the beach is open, and so that allows the sun to, kind of bake the sand to remove some of that E. coli. We will test for culture base Monday through Friday, and then we'll do weekends if there was an exceedance on Friday, if there's an exceedance on Saturday, then we go out and test again. And then we also do qPCR Wednesday through Sunday, and then we regrade the beach as necessary, so that's quite often. And then we also dug a channel to drain the lake. And so every time there was a storm or really heavy water, big waves, we had to go out there with a bulldozer and actually regrade the beach and dig a channel and let the water drain. And so this presentation is actually the steps that we're taking before the restoration actually happens. No restoration has actually happened at this point. We're just sort of figuring out like what are our options, and so we're in the process of finding funding. We don't have funding right now, so if any of you guys want to give us a grant, we'd be more than happy to take it. And also, we were able to do the survey because of the coastal management grant, so thanks to you guys as well. And so, Bill.
Thank you, Carol.
I'm going to sit.
So the park district asked us to try and figure out why this was happening. The beach, which always was high and dry up until a number of years ago, all of a sudden has this huge lake, and it's probably 150 feet wide. And when it gets deep, people can't walk across it. There's a layer of muck in the bottom of it, so it really does destroy the character of the beach. It's a significant problem. So we were tasked with defining how this beach has evolved to its current state, why the problems are happening, and then come up with some concepts to start the discussion of how we can potentially resolve the problem. And we were asked to use a sustainable design approach, which is environmentally sensitive, limits hardscape, because as engineers we know how to fix this with steel and concrete, but to do it with a softer edge is going to take a lot more thought. So that was our mission. So this is the original design drawing on the left, back in 1920s, 28 or so. And the Montrose Peninsula is entirely constructed of fill. So not only the beach, but the entire landmass was not there. The water depths when they built this were probably 20 to 25 feet. So the beach formation itself is anything but natural. They did start the beach. So on the right you see an aerial photograph that's pretty recent, and the red line is where the original shoreline edge was designed to be. And the blue line on the left drawing showed their vision of where the shoreline could extend to, which is really not possible because they have it going out to the pier at the top of the picture, right out to the edge, and the water's probably 25 feet deep out there. And once the toe of the sand beneath the water progresses out to that point, it starts to divert sand to the south. So it would never get to that size. So we thought we'd look at some remnant, original, naturally developed beaches, and there are remnants of these around the Great Lakes. This one is at a forest preserve up at the state line of Illinois on the north end. And you can see these vertical lines that are somewhat parallel to the shoreline. And this is a pretty classic dune and swale formation. So if you have a good supply of sand, which we probably did 100 years ago, and the sand tends to accrete and expand the beach out towards the lake over time. And as it does this, it forms these ridges and swales. And we see this happening all around the lakes historically. So this is a close-up, and you can see the distances between the ridges of the dunes with the swale in the middle. It's about 150 feet, and that's not an unusual distance that we see. So I compared that with the Montrose swale, and we have more than twice that width on the Montrose swale, with 180 feet from the trough to the ridge, so it's about 360 feet across. And it's not surprising because of the way this is formed. We have much finer sand than you would normally have because a lot of the sand is intercepted north of us. And finer sand doesn't stand up as steep to the wind, and it doesn't hang around as long because the wind can pick it up more easily. So we looked at historically what has happened before Montrose went in and afterwards. And so Montrose Beach is the red star at the bottom. And all the yellow stars are significant man-made influences on interception of sand. The predominant littoral drift in Chicago is, of course, from north to south. And anybody who built a structure that can retain sand is going to steal sand from the environment, and that's less that makes it down to Montrose. So these and many other man-made structures in Illinois created a situation where there really wasn't that much sand in the environment. A couple of other nearby beaches just to show geometry relative to when swales form. This is North Avenue Beach, a couple miles south of Montrose, and we have about a 200-foot wide beach, and that's as wide as it gets. It's a man-made beach, and the structure, that's the stable width of that beach, and you don't ever see any swales on this beach. This is Osterman Beach to the north of us, which always has a swale. The beach is about 400 feet. And it's not a classic swale formation just because of the odd orientation of the beach to the wind here. But down in the quiet area at the south, there's always something down there. And again, back to Montrose, just to show that our beach is now 500 feet wide. I believe the length is a half a mile. This is a microtopography of the swales, and you can see it's not a continuous swale, and that's because of the activity of the park district. They're constantly grading access pathways for people or for venues, like volleyball venues and whatnot. But from this we get a sense for the depth, and it's about 2 feet deep from the ridge line of the swale at the water edge to the bottom of the trough. So to come up with a design concept, we need to really understand how this beach is moving around over time and how it's evolved. So we have a lot of information from the 1920s to present with original design documents, aerial photographs, starting back as far as the early 50s, and a lot of other documentation that helps us see how this thing grew and moved around. The red line shows what we think is the lakeward limit of the sand on the lake bed. We don't have a complete bathymetric survey yet, but we have some evidence to show that this is where it is. So we think that we're starting to now bypass sand, so the beach can still grow a little bit more, but not to the extent that it has in recent years. So we did this analysis of from 1933 to present, in terms of how the beach has eroded or accreted sand. So we broke up on the left side here is the beach from north to south. We broke it up into 5 segments, so 5 pieces of pie. And then each one of these segments, there's a horizontal line next to it. And that line shows over time, from 1933 to present, how sand has accreted or eroded. And we correlated that to the lake level trends. So at the bottom here you see lake levels. So we broke up the time scale into segments that reflect periods of rising lake levels, falling lake levels, or stagnant levels. And we found out the typical, as you would expect, when the lake level rises, you get a lot more energy near the shore from the waves. So you have a lot more erosion and the beach shrinks. And when the lake level is dropping, the opposite happens. When it's stable, the beach tends to grow. So all that made sense. What didn't make sense is up until 1988, the accretion and erosion process looked a lot different than what happened since 1988. And so there's no correlation between those two big periods. So we started looking at what was happening north of us. And as an example, the two big beaches north of us, Osterman and Loyola, had not fully formed. They take decades to form when they're man-made structures and they're as big as they are. So they were intercepting a lot of the sand, as well as the fact of Chicago area doesn't get a lot of sand because there's the Great Lakes Naval Station Harbor, Waukegan Harbor, there's all kinds of stuff, man-made stuff in the way. So there's not a lot of sand in the environment. So essentially, up until 1988, from the original creation, there was very little movement of the beach. But then from 88 forward, it just took off, and we were getting 10 to 25 feet of new shoreline every year throughout that period. And part of that was the fact that the lake was relatively low and stayed low for probably a record period of time, 13 years or so. But the bigger part of it is there was more supply available. And the net of it is we found after 1988, we're getting about 10,000 cubic yards of sand depositing. Only 1,500 of that is ending up on the beach and expanding the shoreline. About 6,500 of it is ending in the south end, down in this area. There's a huge dune that formed, and it has tens of thousands of cubic yards of sand that's been depositing over time. And then another 1,000 or two is either blowing over the pier at the south end or diverting around with the littoral drift. And this is just another way of looking at it. So the historic evolution of the beach kind of meandered from here to here, from 1933 to 1988. And from 88 forward, it went from here all the way to here, and recently backed up a little bit with the higher lake levels. So taking this into account in the design, we feel like the beach is not going to erode dramatically in the future, to the point where if we do something to solve the trough and then find out that the lake solves it for us, we don't see that happening. And the beach could grow a little bit more, but again, we don't think it's going to grow to the point where we have two swells instead of one. So from a design perspective, we have to really understand the wind and the waves. And this exhibit on the upper left, you see we have a wave rose that just talks about the percentage of time you have waves attacking from different directions. And as everybody in the business knows, the mean energy is coming from the north-northeast. So that red arrow is pointing in the direction of the mean energy, and it's, as you can see, the orientation of the beach is perpendicular to that, which is very typical. And then the wind is different, and I've got a wind rose on the upper right. It shows the range of directions where most of the wind is coming from that it affects this beach. And the winds are pretty much, the mean energy is going this way. So you have the waves and the littoral currents delivering sand to the beachfront, pushing it up on the ridge of the beach right at the shoreline. And then you have this huge wind field of very fine sand, and the wind acting on it going in the southeast direction. So we're getting a lot of sand, but the stuff that's up on the beach gets blown away. So the beach edge gets plenty of supply, but inland it's being eroded. So that's how this trough is formed. We also looked at groundwater, and there's probably about an 0.8 of a foot drop in the water table upland to Lake Michigan. On the beach, the water table is essentially Lake Michigan, as you would expect, maybe 0.1 of a foot higher. And this is a cross-section that shows the from land to water, and the trough is in this area here. And you can see that the water level here is almost identical to the lake, and the level of the land is actually below the lake. So what you're seeing in Lake Montrose is actually Lake Michigan, translated through the groundwater. And as well as the water's edge experiences wave action, the water level is not that much below this ridge line of sand. And so when you have a storm, the level of the lake will tilt up about 2 to 3 feet, depending on the severity of the storm. That's the surge. And the wave's right on top of that. And 2/3 of the wave is riding on top of the water. So these waves are just coming right over into the lake. So it's continually being filled up by wave action. And then it'll remain perched for a little while, and it gradually seeps through the sand back out to the lake again. We also looked at rain, and rain was not a significant factor in this case. So to come up with a design concept, short of building a very hard structure that would completely restructure the beach, we decided to try to create a perch beach using dune construction techniques, and to do it in a phased way so that we can watch how it performs as it expands with minimal structure as best we could. So we have this 3-stage approach that we came up with. And the first stage is going to start on the south end of the beach with a dune formation. And then we work on that dune to vegetate it, and then we slowly expand it to the south or to the north. So the first stage is essentially as simple as a sand dune around the perimeter. Here's the swale. So we'll start to encroach into that swale a little bit using fencing and plantings, and create a break in the wind field so that we have some sand deposition increasing north of this and some within the dune structure. And this is what you would expect it to look like. And we'll use standard vegetation for dunes and dune fencing. Then the second phase, we would, as need be, we'd place more sand within the dune structure. And we'd even consider dredging here if our suspicions are borne out to be true that this is diverting, it's going to go into the harbors where we don't need it. We would take this sand and beneficially reuse it as a fill, and then vegetate up that surface and creating pathways and venue spaces on the sand for the beach activities. And then slowly work this concept farther to the north. So the original work would be up here, a little bit higher on the beach. As we expand this out, we'll see when we have to put some type of armor on the edge of that perch beach. And we know these perch beaches, if they're well vegetated, they don't erode quickly if you're far enough back. So we'll have a chance to react and not react too quickly by putting hardscape out there. But we think at some point we're going to have some armoring on this edge to keep that beach in place. So this is just a concept plan. As Carol said, we don't have any funding at this time. It's really meant to get the discussion going so we can start thinking forward about how do we apply for funding and how do we want to go about evolving this solution. Thank you.
I think we have time for maybe one question, if anyone has a question for Bill. All right, thank you. All right, moving on, we're going to hear from Chelsea Weisgerger. Oh, did I say it wrong? I think I did. All right, sweet. From Michigan State University, she's going to talk about dramatic long-term improvement in E. coli at a Lake Michigan recreational beach. Thank you.
Yeah. Hi, everybody. Like she said, my name is Chelsea, and I'm from Michigan State. Before I get started here, I want to make sure I send a quick shout out to my parents. They're listening online via WebEx here, so hi Mom, hi Dad. Love you guys, and to everybody who's listening on WebEx and everybody who came here today, thank you so much for sticking around for the last day of the conference here, because I am super excited to talk to you about a project that I've been working on here with Richard Whitman and Mantha Panikumar. And we've been looking at long-term E. coli trends in Lake Michigan beaches. And we're trying to figure out what they're attributed to and how maybe quagga mussel-induced water clarity changes are contributing factors here too. So of course, with any sort of long-term data analysis or project is a big undertaking here. And in our particular case, it involved compiling 72,588 monitoring records from 65 beaches along Lake Michigan shore over the course of 15 sampling seasons between the years 2000 and 2014. And as we can see from the study area map here, at least compared to Holly's map that she put up on Wednesday, we are missing a few of the beaches. We did not include all of the beaches on Lake Michigan because that would have made it for a gigantic data set, and we already have a pretty big one. So we were a little bit selective with our beaches, and we used a priori analytical criteria to determine which beaches we wanted to analyze. So of course we're looking at a 15-year time frame for our analysis here, and we figured that the best way to really look at the differences over time would be to split that time period straight in half into pre and post 2007 sub-time periods here. And then we can compare those and see how they've changed over time. And so in order to do that, we needed some beaches with a lot of data that they sampled both before and after 2007. And we also wanted some beaches that use consistent EPA compliant protocols so that they could be comparable. And of course we wanted, like I said, we always want a whole lot of data. We wanted to select some beaches that gave us at least 504 records over the course of at least 12 sampling years. And then finally, we really wanted to look at Lake Michigan effects here. We didn't want to look at any sort of rivers or islands or inlets or anything. That's for future research. So we were careful to avoid those types of beach areas that were highly influenced by things other than Lake Michigan. And so, of course, as a result of compiling and analyzing these data, we did find that 31 of the 45 selected beaches in Lake Michigan experienced dramatic, statistically significant decreases in E. coli between pre and post 2007. And the one beach that we see up here, the red one, the red bar, the lonely red bar, is actually Bailey's Harbor Beach up in Door County, Wisconsin. And we did have several beaches that did not change significantly, but we also had over 2/3 of our analyzed beaches decrease significantly. And as you might have noticed from the map before as well, we did not include Michigan beaches in our analysis because of these a priori analytical criteria. But had we relaxed these analytical criteria and looked at the state of Michigan beaches, we would have seen a similar trend. In this particular case, 54% of Michigan beaches showed a significant decrease in E. coli over time. And what's interesting to note here, let's see if the pointer will work. Nope. Okay, is the four beaches that actually increased over time here. And those 4 beaches are all sampled from Sleeping Bear Dunes National Lakeshore. And the interesting thing about Sleeping Bear Dunes is that prior to 2007, they did not use a 2-step resuscitation and incubation period for the E. coli. They basically took the E. coli from the samples and put them directly into like a 45-degree Celsius chamber, which in a lot of cases basically fried the E. coli before they had a chance to really culture. So what that ended up doing was artificially underestimating the daily E. coli counts for Sleeping Bear Dunes beaches, and therefore also artificially overestimating the change between pre and post 2007. So that's why we see a little bit of an increase anomaly here for Sleeping Bear. So of course we also wanted to look and make sure that we had good frequency distributions of the E. coli too. That's an important part of statistics. So we have 2 big take-home messages from this slide here. The first is that pre and post 2007 frequency distributions for E. coli counts do seem to follow a fairly normal pattern, if potentially skewed toward lower E. coli counts. And the second here is that the red line, which indicates pre-2007 data, actually shows higher frequency of E. coli, higher frequency of high E. coli counts. And this is particularly true for the area to the right of the line here, which is the area that's above the beach action value of 235 NPN per 100 mils of water. So that kind of corroborates this idea that E. coli has gone down over the course of the study period too. So in addition to just E. coli counts, we also wanted to look at E. coli seasonality and how that's changed over time here. And we can see from the graph on the right here that in pre-2007, there is a strong linear positive relationship between the day of year and the E. coli count. And the R-squared for that relationship is 0.747, which is pretty darn good, if I do say so myself. And but what we see in post-2007 is that this sort of relationship diminishes quite a bit. It's still a relationship, it's still positive, it's still linear, but the R-squared value goes down by over half to 0.302. So something changed within this time period in Lake Michigan. And we have a hunch that it might be due to these guys, our best friends, these great draceniid mussels that have invaded the lakes. So for those of us who need a little bit of a refresher on mussels, zebra mussels first came into the Great Lakes and invaded Lake Michigan in the mid-1990s. They were quickly followed in the year 2000 by quagga mussels. And these quagga mussels are better adapted to the Lake Michigan habitat, so they were able to successfully outcompete and displace most of the zebra mussels in Lake Michigan by the year 2010. And their densities are incredibly high, up to 10,000 per square meter in the lake. So, and of course, these mussels aren't just, chilling at the bottom of the lake, not really doing anything. They're actually having pretty profound effects on the lake ecosystem. So they do kind of switch around the lake energy a little bit, move it to the deeper water, which changes and decreases overall lake productivity. And we've seen this documented actually in the reduction of the Lake Michigan spring algal bloom that previous research has documented. And now in addition to that, these mussels are also incredibly adept filter feeders. So they get into the water, they filter basically everything in the water. They decrease all of the particulates, or well, they filter most of the particulates, thereby decreasing turbidity and increasing water clarity in the lake. And this has actually been documented as well in previous research from Karen Binding and her colleagues. They utilized some aerial imagery and satellite imagery and modeled the water clarity in Lake Michigan over time. And what they found was that there is actually a 44% increase in water clarity in the near shore of Lake Michigan. And most of that increase has actually happened since the year 2000, which coincidentally is when the quagga mussel first invaded the lake. And so water clarity, I guess it makes the water look pretty, but it's bad news for these E. coli and the bacteria in the water. So E. coli tend to be incredibly susceptible to UV radiation. As we can see from this graph here, pretty strong relationship between length of UV or solar exposure and E. coli counts here. We have an R-square value of 0.868, and that just kind of shows that E. coli are really, really susceptible to this radiation. And this was actually done in the year 2000 as a mesocosm experiment. But we're seeing the same sort of pattern borne out lake-wide in Lake Michigan here. So as we can see from the graph here, the line that indicates water clarity seems to be going up over the years, and sort of conversely, the bars that indicate E. coli concentration are going down. So that kind of helps corroborate this idea that there is some sort of relationship between water clarity and E. coli. But we didn't want to stop there. We didn't want to call it good and say, yep, it's all water clarity, no problem. So we wanted a little bit of validation. So we enlisted the help of Mantha Panikumar and Amar Safai at Michigan State University to help develop a coupled hydrodynamic and E. coli fate and transport model, which is kind of a mouthful, but what it does is it takes all sorts of parameters, things like meteorological variables, bathymetry, turbidity, wave and current characteristics, and puts all of those parameters together in a big long equation, just like the one that we can see down here. And what that does is that model will spit out kind of a predicted E. coli concentration given those conditions. And so for our purposes, we wanted to track the changes in E. coli. So what we did was we took a baseline model with just generalized normal conditions and looked at the E. coli from that, and then we ran the model again and changed this K sub E value, which indicates the light extinction coefficient, which we used kind of as a surrogate for water clarity. And so what we did was we altered this K sub E value in proportion to how water clarity has changed over time in the lake. And we ran the model again. And what the model ended up predicting was a 4% decrease in E. coli between the two conditions. And so we were pretty excited about that. It predicted a decrease, and we saw a decrease, so that matched up. 4% seemed a little bit low to us until we kind of thought about what the model was actually modeling. And so this model was for one beach along Lake Michigan shoreline. That beach is Ogden Dunes Beach in Indiana, which is in close proximity to the Burns Waterway. And so, of course, this beach is being heavily impacted by the outlet from the plumes and the outlets from this Burns Waterway. And that could potentially be masking some of the changes in E. coli that we would otherwise see at some of these other beaches. So overall, pretty happy with the results here. But again, it's never enough. We still wanted a little bit more validation to see if we're, on track here. So we used Lake Erie as a reference condition to see if we could compare it to the conditions in Lake Michigan and see if it kind of followed along there. And what we found, again, this is from Karen Binding and her colleagues. They published in 2015. We found that the nearshore Lake Erie water clarity actually decreased, by nearly 15%, which is a far cry from the 44% increase in water clarity that we saw in Lake Michigan. And correspondingly, we looked at 20 different Lake Erie beaches, and not one of them decreased in E. coli over the course of the study period. Now, these are all Western Lake Erie beaches, so there's all of this about the HABs and everything like that we didn't even get into. But we are seeing sort of an opposite effect in Lake Erie as what we saw in Lake Michigan, which we thought was interesting and gave us a little bit more confidence. And that led us to our hypothesis here, which is that these invasive descended mussels have come into the lakes, and their effect has been kind of twofold. Firstly, these mussels, as I said, they're incredibly adept filter feeders. So they are eating a lot of the E. coli. The E. coli that are attached to particulate matter in the water are getting filtered out just like everything else that they're filtering. But we also think that these mussels, due to their filtering capacity, they're just clarifying the water in general, which allows the sunlight to penetrate a little bit deeper than it would have normally, and allows it to kind of inactivate the E. coli's DNA and kill a lot of the E. coli that's in the water column free-floating. So by the numbers here, there are a lot of numbers, and I don't expect you all to like memorize any of them or anything like that, but the three that I really want to draw your attention to are the nearshore water clarity change in Lake Michigan, which was an increase by 44%, as I mentioned before. And then the corresponding E. coli change, which was a decrease of 34% in median E. coli and a decrease of 10.2% in mean. And then for all of the beach managers out there, what we're all concerned about, the beach advisories and overall sort of beach health for users, we actually saw a decrease in the probability of beach advisories of nearly 8%. So the chance that any given beach on any given day is under an advisory has gone down from pre-2007 levels of 19.6% to post-2007 levels of 11.7%. So of course that seems to be pretty good news. But of course there are a lot of other implications there. The first and most controversial of which is this idea that this might be a positive impact of an otherwise nuisance invasive species. So a decrease in E. coli is good for human health, But we can't discount the fact that these mussels are doing all sorts of other stuff to the lake. And it's leading to this phenomenon like lake electrification and the clarification of the water, decreases in productivity and all that good stuff. And so there's this idea that, clear water is safe water. And that's not always the case. Clear water does not always indicate safe or clean water or a healthy ecosystem. So we do have to look into that as well. And then also, this kind of calls into question the efficacy of E. coli as an indicator for other pathogens. So we all use E. coli as an indicator, hoping that it aligns with the pathogens that we're really concerned with human health. But if E. coli is sensitive to light inactivation and quagga mussel effects in a different way than some of the other pathogens, then testing for E. coli as a surrogate for these other pathogens becomes kind of moot. So in the future, we're going to try to look into comparing these sensitivities of these pathogens to E. coli, as well as developing quantitative microbial risk assessments for these beaches and taking into account these new sort of impacts of quagga mussels. And so, again, we all, we want to make sure that we're doing things right and we're covering all of our bases. So we did look at some alternative hypotheses. For one thing, we looked at some local effects like restoration and management. And we love restoration and management. We have no doubt that they are having an impact on these beaches. But in terms of our data here, what we're seeing is a lake-wide effect on E. coli. And the restoration and management efforts do tend to have localized effects. So we do have a little bit of a spatial mismatch there. And then we moved on to some regional effects, things like climate change and lake levels. And we did some preliminary analyses of those, and we really couldn't find any sort of compelling relationships between these regional effects and E. coli changes. Of course, that doesn't mean that they're not there, but we just need to dig a little deeper into that as well. And then finally, direct mussel predation. We think that this is probably the biggest alternative explanation that we could find for this. And we do think that there is a lake-wide effect on E. coli due to direct mussel predation. We're just not sure what the relative impact is compared to light inactivation. So to wrap up here, because I'm sure I'm over time, we had a lot of people help us out with this project here, including all of the beach managers who helped us with compiling all of our data, as well as colleagues at both the university and professional levels who gave us insight into ecology and biology of the lakes throughout the process. And we want to extend special thanks to Greg Kleinheinz of University of Wisconsin-Oshkosh, Ellen Marsden of the University of Vermont, and Don Schlesser of USGS for their specific contributions. And as with anything, these results should not be taken as sort of any end-all, be-all. Instead, they should be an impetus for continued scientific discussion and debate. So as such, I would be happy to continue this conversation with any of you here in person today, over email or over the phone. So thank you so much for your attention, and I look forward to talking to you.
Does anyone have any questions for Chelsea? Oh, all right. Okay. We have a couple minutes, so.
Chelsea, is there any correlation to your findings in relation to high water levels now?
We've only done a little bit of. Oh, okay, sorry. The question is there any sort of correlation between high lake levels? And we've done a little bit of preliminary studies there, and we haven't been able to find any sort of significant correlation just yet. But we are going to continue working on that as well. Raj?
Just a question. You said the hydrodynamic model predicted 4% decrease in E. coli?
Yes, that's correct.
So given that complex model with so many variables, and you haven't talked about calibration of that model, 4% seems to be within the margin of the single-digit decrease. So how confident you are with that 4%?
Right. Okay. So the question was, since we had a 4% decrease in our hydrodynamic model, that seems to be within the margin of error. So how confident are we in those types of results? And the answer to that is we're fairly confident. We were happy to see that it did sort of correctly predict the directionality. So that was promising. But you're right. It is within the margin of error. But that's why we kind of went to sort of greater lengths to try to further validate what we found too. So, so yeah, that's kind of another option for future research too, is to continue to calibrate and figure out what's kind of going on with this model too.
We maybe have for one more, maybe two.
Okay.
Continuing on with lake levels, the 15-year period of low water ended in January 2013. So we've had 4 summers of higher water. We gained 4.5 feet. By direct observation, my team tracked 15 miles off the shore of Traverse Bay, and finally, after the 4th summer, the crud that had built up as a result of low water has finally sheeted off. It looked a little like old wet wallpaper that might have spun off. It took all summer for it to mix with the storms, and it's now gone, and we have wonderful clarity. But I don't know what was in that crud, but E. coli could have been part of it.
That's true, and that's another thing that that is kind of an unknown factor that we're talking about is E. coli isn't just in the water. It's being washed up. It's in the cladophora that washes up on the beach, and it's in sort of the detritus that's around there too. So so that is a possibility, definitely, that we're seeing that too. And of course, long-term studies, the future research implications for that is continued monitoring and seeing exactly what happens now and into the future. So we're excited to see what we find with these changes in lake levels particularly.
Mike, did you?
Yeah, that's a great talk. Thanks, I appreciate it a lot.
Oh, thank you.
One of the factors I thought might be really useful is to look at the decline in nutrient level inputs going into the lake over the last 10 years. So adding that to the model might add less dimension.
Okay, fantastic. Thank you, Mike. He suggested adding nutrient loading to the models as well in order to make them a little bit more strong.
All right, well, thank you, Chelsea. I'm sure she'll be happy to answer more questions after. Our final talk for today is given by Alice Bailey from Environmental Consulting and Technologies. She's going to be talking about protecting your investment, a candid look at beach restoration, maintenance, and longevity, and I think this will be really interesting, so thank you.
Thank you. So I'm an engineer at ECT, and something that I get to do is be a part of a project from its early conception through implementation. But what I've learned is that there is life after construction, and that needs to be a focus through every stage of the project. So I'm going to talk a little bit about that, things that you can do for your restoration project to assure its long-term success and protect your investment. I'm going to start by telling a little bit about the Sherman Park Beach Restoration Project in Sault Ste. Marie, Michigan. It's on city-owned property. And the Chippewa County Health Department had become concerned about the number of beach closures that the site had experienced over recent years. And they attributed this to excessive stormwater runoff, carrying with it pollutants and sediments into the river. So with GLRI funding through the DEQ, they were able to put a plan in place to restore the beach. The plan included a series of rain gardens, jetty removal and beach nourishment, and dune grass plantings. So in 2014, a construction contractor was brought on board and was able to install the rain gardens for us, and the health department was able to rally a group of volunteers to install the plantings. And about 800 cubic yards of sand were brought into the beach, and about 26,000 plugs were planted. Also included in the project were a series of cord walks and Moby mats, which allow access to the river, reducing the potential for erosion due to foot traffic. And educational signage to inform the public of the importance of the project at the site.
So we had a successful implementation, but that's not the end of the story. Most of what was included in the project was vegetation, so that continued to grow, to evolve, and that is when maintenance became more important, or a center focus to make a long-term project successful. So with that in mind, we developed a site-specific maintenance plan for the project that was given to the city, who would be maintaining the project. And the city has done a wonderful job over the last couple of years going through the checklist that we provided, going through the plan and making sure everything was implemented and the maintenance has been carried out. So I just have some pictures of the site over the last couple of years showing how it's evolved. Rain gardens. So we've seen a successful project. You can see here the people using the site, and we attribute that to the wonderful work that the city has done at the site, but also keeping maintenance part of the discussion from the very beginning. The city was involved throughout the entire process. The health department was involved throughout the entire process. We identified who was going to be maintaining them and helping educate them to make sure that they are champions for the site. The consistent communication and relationships throughout the duration of the project, and then of course the formal maintenance plan and the city's ability to follow through with that plan. So Christine Daly was here earlier, but she had to leave, and I wanted her to kind of give her perspective on the project. But one thing she wanted me to note to you all is that they've had one beach closure, and she thinks it's due to the good quality at the beach, that there was a big mayfly hatching, and that drew birds to the site, and so that's what she thinks caused that one beach closure, so the bird activity at the site. So with that success, I want to dive a little bit deeper into maintenance and things that you can do to maintain your site. Every site is going to be different. Every BMP or piece of green infrastructure that you install at a site is going to be different, and the maintenance that goes along with each of those is going to be different, but it's always the key to the long-term success of your project. There might be a misconception that with BMPs or green infrastructure there is no maintenance involved, but there is maintenance. It just might look different than what you might be used to seeing with traditional infrastructure. So I'm going to go through a few other projects that we've implemented and some lessons learned from those projects. They're not all beach projects, but I think that the BMPs installed and the lessons learned can be applicable along our waterways and at our beaches. So I'm going to start with the city of Southfield. One of the first BMPs that they installed was you can see the pervious pavement, but also the bioswale along the center. And they didn't have maintenance in mind when they started. So the vegetation got a little unruly, and they ended up transferring it to turf grass because it just got out of control, and they weren't sure how to deal with that. So with that in mind, at Beachwoods Park in Southfield, they knew maintenance was important, so they identified a champion early in the project to make sure that this could be a long-term success. And it's been installed probably about 5 years, and they have had great success with that specific project. But they understood the difficulties of maintaining something like that, the special skills that you might need in order to maintain that. So with the Inglenook Park bioswale that we put in for them, they wanted a simpler plan. We did a simpler planting plan with less species involved, a more formal setting, and that allowed their staff to be able to only have to know about a few plants and know what to weed and how to maintain that. And that's been successful. It's probably been in maybe 2 or 3 years now. So I think the moral of the story with the city of Southfield is that keeping maintenance, of course, part of the discussion from the beginning, but then it can drive your design. You can cater to those maintenance expectations for whoever's going to be the one to take over the project after completion. So we heard a little bit about Chrysler Beach from Sherry earlier, which was great, so you could see all the wonderful pictures that she had in her presentation. And I want to talk a little bit about the city's involvement in maintaining that site. There was 5 rain gardens installed as part of that project, and the city was very involved from the beginning. The DPW staff was very involved from the beginning of the project, and they understood the maintenance required and the differences in this type of project as opposed to a traditional stormwater or other types of infrastructure, the maintenance required there. So we were able to put together a quite detailed maintenance plan for them that had, you can see the pictures of the different species that we installed, so that they could then translate that to their staff and show them these are the good plants, these are the bad plants, these are the things that need to be done at these rain gardens. And they have been doing an okay job. They are certainly champions for the project, but as with any DPW or any municipality, there's some turnover in staff, and they are just ongoing. They are faced with ongoing training that's needed for their staff. So the rain gardens are doing great, but they may not be reaching their full potential as far as getting the weeding done and some of the other things that need to be done on the project. And in Belle Isle, Detroit, Michigan, we installed a natural shoreline area. We removed about 300 tons of debris from this site and installed this vegetation to restore the site. We were able to involve a group of high school kids for volunteering to plant some shrubs up top. But unfortunately, we came back about a season later and the shrubs were gone. So somebody mowed them over, and we can see some of the stubs there. And so what we learned from that is that, again, the conversation and the continued conversation with the folks maintaining the site. Obviously, they were mowing and they didn't realize what they were mowing over. So an ongoing education and then, of course, some signage would have been helpful at this site. So luckily, we actually did another length of shoreline adjacent to this one. So we have plans to put up some signage and to help protect that effort. So I feel really bad for those kids who have come back to the site and might see their shrub gone, because they did an awesome job putting in the plants. And then this is in New Baltimore, Michigan. This is a park that's located really at their center of their city. It's kind of a focal point, a gathering place. They hold festivals and events there. They have pavilions. And they were faced with a similar situation as with Sherman Park, in that they were having high E. coli counts and attributed that to the stormwater. So we installed a series of rain gardens, some pervious pavement to capture and treat the stormwater. And we installed a more of a formal kind of rain garden because it was sort of a formal setting. And we knew that this was a kind of high profile location for the city. So we set aside a healthy budget for that first year after implementation to actually hire a contractor to come in and do the maintenance on these rain gardens, so that we can assure good kickoff to the maintenance. And so they've been installed about a year. These pictures were just taken this last summer, which would be a year after it was constructed. And they really have taken off beautifully. And we're excited to see the city take over and hopefully continue that success. And the moral of the story there is obviously a healthy budget up front would really give a good kickoff to long-term success of the project. And then my last project I'm going to share with you is Danvers Restoration Project in Farmington Hills. And this has been installed for several years. It was a dam removal project with a stream restoration and floodplain restoration component. And the city was able to set aside an annual budget to maintain this property. And they've done all sorts of plant replacement, invasive species removal, and some other things that have really kept the site looking great, operating great. As with anything, a long-term budget set aside to help with that maintenance was really the moral of the story there. So with all these experiences that I've gone through these last several years, the toolboxes that my toolbox I wanted to share with you is that really maintenance should be part of the discussion from day one. Again, try to transform people's ideas that green infrastructure is no maintenance. It might be low maintenance and it looks different. So there's some education and maintenance, or education and training that needs to happen as part of that. Identifying those champions, and if they may not quite be champions, providing that education and training to help get them there and keep them part of the project, get them excited to take ownership. And then as designers, thinking about the maintenance, what the city or whoever's going to take over the project would expect for maintenance, and try to design so that you can cater to those needs. And then budget is always, can always do good things for the project. And early maintenance, again, having that budget set aside, we actually put it in our contract sometimes so that our contractor is responsible for that first year of maintenance. So that can really give the owner, the future owner, a great kickoff to the project. And then again, ongoing maintenance can make the good project a long-term success. So hopefully you can use some of those tools as you embark on any of your restoration projects, and just keep maintenance in mind as you do so. And if you have any questions, let me know. Thanks. Good question.
What would be the range between a budget and a healthy budget for maintenance?
Of course, it depends what you have. Like I said, every site is different. Every every BMP is different. So you have to look at your maintenance plan that you hopefully develop and plan accordingly. We do put, like I said, often put that in our construction budget for a contractor, and we will do it per month. So we actually leave it up to them to provide that unit price. So then we have a monthly budget, and we account for, say it's a year, so it's really the growing season. So we have 6 months of growing season months in a calendar year. So we would have that monthly budget, and really whatever you can afford would be great. But it ranges. Say Burke Park, the example I gave might have been $1,000 a month.
And is it just to get more time, or do you have to have specially trained staff? Like you can't just get the guy that cuts grass, or do you train?
It can be some of both. So the question was, do you need specially trained staff, or can you have your regular staff? Usually we have our DPW or our regular staff, so that's why we put together those plans, those maintenance booklets to help them refine their skills. I know for me, I have a backyard where I've planted a lot of native plants, and as an engineer, I do not know my plants whatsoever, and I call my landscape architect friend to come over and tell me which weed to pull and which one not to pull. So it's hard. It's a special skill. So I don't know if it's any more difficult than what they already do. It's just a different skill that they might need to hone in on, and having some of those resources built into your project budget for throughout the design can really help.
We found a lot of resistance from municipalities when we say the term a lot too, with really no O&M moving forward, but it seems like that's the opposite for the municipality. They're really scared of any O&M, and so how do you navigate that? And if you guys...
Yeah, again, it's that education and training and the conversations. And like I said, it is going to be different than what they're used to. And I focused on vegetation because that's probably where we see the most, I wouldn't call failure, but the most problems with, because we do pervious pavement, and they get street sweeping. They can sweep that. They understand that. If there's anything else that needs to be cleaned out, they get catch basin clean out. They can do that. So using those tools on those pieces of BMPs is something they easily get, whereas with the landscaping, they're usually mowing and they want everything mowed down a certain way, or things are landscaped beautifully and they're trying to maintain that. So there is just that education, and yes, it's difficult, and that's why building that into that first year budget can really help, because then they can see what the potential is, and it can give at least a year of success where they can see what's being done and then how they can then take over.
Clearly, there's opportunities for professionals to maintain these kind of projects, but what about nonprofits? Do they offer some
Absolutely.
help as well?
Yes, absolutely, and we look into that as part of our projects. Also volunteer groups, there's master gardener groups that can help with the early planting and then the maintenance afterwards. They can really take ownership. And then, yes, the nonprofits and watershed groups have those skills in place that can be part of the project, even part of the grant funding. To allow that year or more would be fabulous to help maintain those BMPs.
Any other questions?
Have any of your restorations been affected by the severity of the storms?
I wouldn't say it affects our maintenance, more the design. We've certainly changed the way we design the storms we're designing for. And so I think more it comes into more of the design is what I've seen. The plants are pretty resilient, so we do, when we specify and design, say, a rain garden or something like that, we will have a range of very wet to drier plants. So we build in that flexibility maybe and we come back, and certain plants do take over and certain plants don't. So I think the plants really provide that a little bit of a buffer.
Thank you. So it looks like we're a little early. So we can break now for about 20 minutes, and rather than reconvening at 10:30, we could reconvene at 10:10 or 10:15. 10:10. 10:10, the master has spoken. So 10:10, and then we might be able to get done a little bit sooner doing it that way. All right, thank you.
Yeah.
All right, one more announcement about posters. If you have a poster, they're taking them down right now. Please get your posters. And then Jerry Mills is coming towards the end of this presentation today. So about 11:30, we're going to have him. He's going to come sing one more song. So of us in the room, how many were here Wednesday night and got to see Jerry Mills? All right, so we got to see him. Okay, good. He's coming back to just do one more song for us. So with that, so posters, and at the very end we got a song. So now we're going to go into the next session. And are you our session chair? Okay, so Sarah. Oh, Julie. Julie's on webinar. Hey, everybody. If you want to say hi to Julie, come on up here and you wave to her.
Hey, Julie.
Hey, Julie. And so the reason Julie would be... Hi. Thanks, Julie. So Sarah's here to do your session for you. So here's Sarah to do the thing. Thanks.
Hi everybody, I'm Sarah from Miller Engineers and Scientists. I'm covering for Julie, who is not able to be here today, so forgive me if I screw anything up. I'm working on it. The last session today is shoreline preservation, and our first speaker is Mr. Peter Pittner, also coincidentally from Miller Engineers and Scientists. He has been my boss for the last 14 years, and I get to be his boss for the next 20 minutes. So this is the highlight of my career right here. Peter, if you want to come up, he's talking about revetments as a last line of defense.
Good morning. I have more people left than I thought, but if I can make this work. As Sarah said, I work with her, and she's also our director of marketing, so she put together this little commercial slide, so I feel obligated to go through it. So yeah, we've been in business a long time. We have over a century of professional staff experience in stormwater mitigation and natural design. I think that's her nice way of saying that me and a couple of my colleagues are kind of old, and we've been in the business a long time, so if you add up our years of experience, it comes to a really big number. But more importantly, we have all experience on both the design of over 40 beaches in the Great Lakes, so we've had the opportunity to see a lot of the coast and a lot of coastal conditions. And I apologize if a lot of these slides are repeats from Beach 101 on Wednesday, but I'd like to just go really briefly through a few of our projects because I think it's relevant to what we're talking about today as far as natural beach dynamics are concerned. The first is Egg Harbor Beach in Door County, Wisconsin. Many of you have probably seen this beach or examples of this beach. But you'll notice a kind of a reoccurring theme here. This was a very low, flat, wet beach. There was some hard infrastructure that was disturbing the movement of sand, disturbing the circulation of water in front of the beach. And there was a lot of storm water coming down. There's a very large hill behind this beach. Storm water was coming down, washing over the beach and entering the lake directly at the swimming area. So we came in, and it's hard to see on here, on the back end of this beach, there's vegetation. Dune grass was planted. There was a swale that was installed to intercept the storm water. And to allow infiltration, we built a back dune, which allowed us to raise the grade of the beach, which we could come in and add sand, nourish the beach, raise that beach above, create a healthier beachfront. And you can see it worked as far as people were concerned, a much more pleasant place for bathers to gather. Again, similar, Door County, Ridges Sanctuary, there was a parking lot above the beach that drained directly on. And again, no vegetation on this beach. People like large, flat expanses of sand. That's what they want, not necessarily a healthy condition. We came in and put a small swale in the front of the beach to collect and infiltrate storm water. Again, brought in dune grass, stabilized that dune area, allowed the beach to build itself up, nourished the beach, raised the level of the beach, ended up with a much healthier beach as far as E. coli conditions are concerned. Hi, Julie. This is Sam Myers Park, one of Julie's beaches down in Racine, Wisconsin. Off the edge of this beach, there's a breakwater, no circulation occurring in here. They ended up with kind of a wet wasteland down here. On this picture, you can see a lot of phragmites had been burned off. We designed a series of dunes and interdunal wetlands on this beach. It's in process, kind of a remarkable transformation, but again, beach nourishment, controlled access. Dune grass is not planted in here yet. This is a very recent picture. I think the dune grass may be going in as we speak. And finally, this is Blue Harbor Beach in Sheboygan, Wisconsin, where I'm from, where our office is. This is what is known as the Rice Peninsula. This had been a very active harbor for decades. Coal was brought in here, fertilizer tanks, oil tanks. And as the shipping industry waned, this area was redeveloped into a resort district. A Blue Harbor Resort was put in. We designed a dune area, public access, and again, the stabilization with dune grass. You'll hear me repeat dune grass a lot in here. A very important component of these restorations. The thing that's a little different about the Blue Harbor Beach is because of the infrastructure behind it, we needed to construct a revetment, and that revetment you can see was exposed on the north side of the project, and then traveled inland behind the project to protect the infrastructure behind. But this allowed us to maintain a beach area in front, again stabilized with dune grass and an active beach front. This picture was this year during relatively high or above normal water periods. You can still see we have an active beach in front that people can utilize as compared to the exposed revetment where there is no beach. And why do I bring that up? Why is that important when we're talking about revetments? Because we've seen a lot of examples of beach restorations, and we know that, at least I think aesthetically, they're very pleasing. They're also good for water quality. They're also good for public access. But what we're trying to do, we talk a lot about sustainable solutions. What we're trying to do is mimic the natural conditions of the lake. And that's important because particularly on Lake Michigan, we have variations of water level, which we're seeing right now. We know they're very active and dynamic systems. So if we look at this beach profile here under what we'll call normal conditions, we have our beach face, we have a berm, we have a vegetative stabilized dune that's collecting sand behind there, and we have kind of a happy, healthy condition. As water level raises, as water levels go up, or as storms come in, we have erosion taking place on that beach face. We have sand moving off, and we have accretion of that sand and sandbars offshore. That's very important for a number of reasons. Number one, that sand remains available to the system. And number two, it maintains a shallow near-shore profile, and that shallow profile and those bars are very important in energy dissipation as waves come in, and we'll look at a slide coming up here, but the height of those waves and the energy coming in those waves is directly proportional to the depth of the water. So as we protect our infrastructure inland, those active dynamic beaches are very important and are probably the best way we have of protecting our inland infrastructure. So as we move over and lake levels increase even more, we see the erosion coming in of that dune face. We have that supply of sand that's been stored in our dunes that again can come off, that can accrete in the near shore to serve us, as I had just explained. As water levels then go down again, that sand becomes exposed. That sand is then available to the movement of wind that comes in to our dune grass area, to our vegetated area. That sand is trapped. The cycle repeats itself. That sand's available again for our next high water period. So again, looking at the levels of Lake Michigan, Lake Superior certainly not quite as dynamic, but you look at the levels of Lake Michigan, our normal water level fluctuations is about 6 feet over the last 150 years of data on the lake. So we know we have a very dynamic system. We know we're going to have periods of high water. We know we're going to have periods of low water. The pictures of the beaches that we looked at, most of those took place, the designs around 10 years ago when we talked a little in the last session. We had a historic period of low water levels there. We're now at 2016 and we've come up feet in elevation very rapidly. And I can't tell you when we did the designs of those beaches back in the early 2000s how many people came up to us and said, water levels will never go up again. This is the new normal. They'll never go up, and here we are. So what does that look like? This is a picture of a beach south of Sheboygan, Wisconsin, kind of a series of pictures from the same location. 2010, during the low water period, you can see kind of the expansive beaches we've had. The property owners down here had actually supplemented dune grass, had planted dune grass for the reasons we've talked about. 2014, you can see the water level coming up, erosion taking place of that beach, again, that sand being deposited offshore. And here we are today, several weeks ago in 2016, with the water up. You can see eating the dune face, this very small dune, but dune nonetheless, storing sand that had been built up because we nourished that beach with dune grass. So what happens when we add hard infrastructure to these systems? And we saw some pictures from Chicago in the previous session showing some jetties, some groins going on, and I think if you noticed, it was very stark the way we had sand building up behind those groins. This is the North Federal Pier in Sheboygan, Wisconsin, and again, we're on the west shore of Lake Michigan, so we have a net movement of sediment from north to south. You can see up at this breakwater, you can see the large accumulation of sand here. What that does there is produce a very nice, broad, big beach, which people like. What that does downstream is starve the beaches downstream because we're interrupting the littoral drift, we're interrupting the natural system. So we have accumulation of sand on that side. We have sand-starved beaches down below, which results in those beaches we saw in the first slides where we have slow, flat, unhealthy beaches. Maybe not quite as intuitive is what happens when we add hard revetments or hard structures to a lake shore. This is a picture of a very large revetment that was constructed, I'll say south of Sheboygan, north of Milwaukee in 2006. You can see the large revetment here. You can see this coming out, intruding out into the lake. Again, very nice for protecting this property, but not so nice for the people down drift. Again, this is a little more close-up of that picture, and you can see that was put in 2006. By 2011, we have severe erosion going on down drift of that because we've starved the sand down drift of that hard infrastructure. Looking at a little closer, this is north of that revetment, looking south. In 2011, you can see the face of the revetment there. We're very close to it. You can see we have not a broad beach, but we have a sand beach below that during low water levels, no erosion going on the bluffs on that beach face. If we go down drift of that, south of that, looking north, here's the end of the revetment. This is the situation downdrift. We have no sand on that beach. We have severe erosion taking place, even during 2011 during our low water period, simply because we have a revetment up there that is starving the sand, not allowing the littoral drift of that to accumulate on the downslope face. So again, what's happening here, and I work for an engineering firm, but I'm not an engineer, so I won't get into the math. But wave energy coming in is directly proportional to the water depth. So the breaking wave height, if you can see here, is about 3/4 of the water depth. But more importantly, wave energy is also proportional to that water depth, or to the height of the wave. So wave energy is proportional to the height of the wave squared. So you can see as we go out, energy increases very rapidly as water depth increases. So again, looking at that nearshore profile that we had with the shallowing, with the gentle slope coming in and our sandbars, we're decreasing water depth, so we're rapidly decreasing the energy coming in with those waves. We have the waves breaking over those sandbars, giving up their energy coming in, so we have kind of a natural barrier to the energy coming in with those waves. When we have that revetment, we have energy reflecting off that revetment, so we have energy coming in. We have the reflective energy going out. It's scouring our bottom. It's carrying that sand offshore. We're deepening our nearshore profile because of the scour, so we're kind of working on ourselves. We're ending up with a deeper nearshore, so waves can come in at higher energy because the water's deeper. So we're kind of self-perpetuating a situation there where we have scour going on. We're taking that sand, we're moving it out, we're removing it from the system. So that's how we end up with the downshore sand starvation off those hard revetments, because we're taking that sand and we're removing it, we're taking it out into the lake, we're removing it and not allowing it to go downshore. Another example of this is just south of Sheboygan, very close to those first pictures we were looking at. This picture is taken from the same location. Here the photographer is facing south. Revetments were put in here in the 1980s, tucked up at the historic erosion line, as you can see where the trees are. So again, during a relatively high water period here, we have a little bit of beach. We have a little bit of beach dynamics going on. The photographer turned around. Some of his neighbors decided quite recently in the last couple of years to put a revetment in. Instead of tucking those at the erosion line, they moved them out. We have a situation here where we have no beach. We have that reflection going on. We'll have water deepening going here. So even as we come to low water levels, the situation here will have much less beach as this person does. And consequently, with the erosion going on here, we'll probably be sand starved here. So again, he's going to be affecting his downstream neighbor as time goes on. So just kind of very schematically, if we have revetments, and again, sometimes we're going to have revetments. I understand that we have situations going on with with high water levels right now. We have properties that are in peril because of the erosion. But if we have to put revetments in, we want those revetments located as far inland as possible, so we have as much of that natural lake dynamics going on as we can, so we have that nearshore profile to absorb that energy rather than a revetment, and we're not taking that sand and moving it out of the system. This is just a picture of the revetment that went in at that picture at Blue Harbor that I showed earlier, where the toe of the revetment came in, the excavation was going on, that sand was then used to re-nourish the beach in front of it. And we ended up with a situation that looks like this, or like this, with in this situation, again, during our high water periods right now, we have a revetment that was put in here in the 1980s during high water levels at the historic erosion line, and we have nice, beautiful beach in front of that right now, because during those low water periods, we had dune grass in front of that, allowed the sand to come in, allowed the sand to accumulate, and we still have beach. So just in conclusion, kind of a little cross-section we can put together, kind of maybe the ideal situation if we're able to. On our beaches, if we have beach nourishment in front, we bring that beach up. We establish our dune vegetation, and again, I think Dean's coming up next. The dune grass is really a critical component of this situation. If we have a revetment, get that revetment put back as far as possible so we have our natural beach dynamics going on in front of it. In this case, we saw our stormwater infrastructure and our municipal BMPs taking place behind that. So with that, I'd be happy to take any questions.
Okay, next presenter is Dean Wassink, better known as the Dune Man. He's from Old Paths Inc., located in Holland, Michigan.
Looks like we're getting some batteries put in the mic a minute. Thank you for explaining that and for making those copies. What I find is I talk like crazy and then afterwards it's like a blur when people try to remember what they said. I'd like to thank you for letting me speak here. I'm kind of an unusual person because I'm passionate about dune grass. So what I want you to do is, I'm joking, okay, but I want you to stand up and let's do dune grass aerobics, and that means you get down on your hands and knees and you're going to just do this up and down and twist sideways for 10 hours and you'll find out what dune grass is all about. I'm Dean Wassink. My wife Donna is here with me. We're from Holland, Michigan, and I'm one of the primary suppliers of dune grass in the Great Lakes and actually on the East Coast as well. My latest claim to fame was Hurricane Sandy restoration. I was the last guy in the country with dune grass. And so I was supplying my competitors and I was supplying my own customers. It was kind of a neat opportunity. Dune grass is really unique, and I'm going to show you a little bit more of the structure of it in a second, but it literally grows on the ocean about as far south as Virginia, in that neighborhood. It's sporadically further south, but that means it's salt tolerant as well as something that will grow in fresh water. And so it works great in a parking lot situation where there's salt being spread all the time. Let me give you a demonstration. I was going to actually hand out a piece of dune grass to everybody, but I got thinking about how messy that would be. So what I did was, I'm going to try not to make anybody mad at me here because it's kind of dirty. Okay, dune grass grows to be about 2.5 feet tall, and the way we harvest it is we pull a clump out of the ground like this. These were some clumps that were in my yard, so they have a little darker soil on them. And we start to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There's 12 divisions in that one clump. Now, each one has its own eye, and sometimes you can see the roots underneath it. This is a good example of that. But sometimes
all you're going to see is just a clean plant like this, and you're too far away to see it. But on the base of each of these stalks are next year's plants. So the only thing you need in the ground is that eye. So we plant it about 6 inches deep, and that eye is 6 inches down, and it will elongate to whatever it takes to reach the top of the soil. The top is very persistent. It can take 2 or 3 years to actually rot enough to be able to rake it out, but that creates just an incredible situation for holding soil, holding sand in a wind situation. So let me just show you here the next slide. This is down in Michigan City, and when the lake waters came up, it exposed what the dune grass was doing. And so what you can see there, let's see if I can make the picture work. No, I'm not getting it. Or I'm moving it. There it is. What happened was the dune grass originally was at this height. When the lake waters dropped, it exposed a lot more sand, and the sand then picked up on the wind, covered the dune grass, and that was another year's worth of growth. So it elongated about 2 feet, came out the top, reestablished itself, grew for the summer, and then that was the next year, and then the last year. And of course, when the lake water came up and the waves started to beat against it, it took the sand away. But the dune grass worked as a sand trap. And it also gives an explanation why there's a lot of misunderstanding about dune grass. Dune grass really only likes to grow 6 to 8 inches deep. People think dune grass has got roots that are, that goes down 30, 40 feet. Well, actually, it's the other way around. It has roots that are 6 to 8 inches deep, and it grows through the sand, and as there's accretion and the sand builds up, the dune grass stretches every year. It can literally stretch through 3 to 5 feet of sand, and maybe some of you have seen that. So now it's tied that whole dune together, and it just keeps increasing in height. All right, the timing of propagating dune grass, there's 2 ways to do it. One is in the spring and fall as a bare root plant when it's dormant. We normally, in lower Michigan, we start harvesting end of March as soon as the ground thaws. We dig until about the end of May. At that point, it's growing too fast for the roots to actually establish. I've had really poor success if you get into June, July, and August. Will it grow? Yeah, sometimes. But the main thing that happens is your eye here, you've just ripped it out of the ground, pulled it apart, and you're sticking all that green in sand. And usually without irrigation, there's no way for that root to grow fast enough to carry the top. Now it might burn down, which it sometimes does, and then restart growing again. But your odds of survival are much better in the early spring. And then after September 1, as soon as it cools down, we sell dune grass up until the ground freezes. So then, even though it's green, it's essentially dormant, and it's putting its energy in its roots. And so it's very transplantable the month of September, October, November. We actually planted the day before Christmas one time. Typically we plant, it's about 6 inches deep. And you notice I even bought a nice new shovel here. There's several different techniques for planting. And what I like to do is, first thing I do is assess who is doing the planting. The easiest way to plant is you turn the shovel backwards, one person sticks it in the ground and pulls it back, and the second person slips the dunegrass sprig behind it. This person then does another hole, and this one packs it tight. Okay, so you get this little system working with two of you, and then one person is bending over, and you can rotate and get some different action. Now, we do it professionally, and to give you some perspective, a normal homeowner can maybe plant with two people a couple thousand a day. A landscape worker who is working at a decent rate by himself can typically plant 2,000 to 3,000, maybe 4 if they're good. My guys plant 10,000 to 15,000 per day per guy. Okay, it's that much difference knowing a professional technique. So let me explain the technique, even though you may not ever do it. What we do is we take a shovel like this, and we actually cut the blade into a point. Now, when I show you some pictures in a few minutes, you'll see that the guys have these. Okay, so this shovel is cut to a point, and we cut the wooden handle. That's why I bought a wooden handle one, and we round it off. So now they've got a heavy-duty trowel, right? Missing the handle here, and it's pointed. So what they do is get down on their haunches, and they take one hand, has got, each bundle that I sell has 100 plants in it, actually 110 to allow for some that don't make it. So they make small handfuls. They stick the trowel in the ground, and as they stick it in the ground, they've taken this hand and they've bent it. Can you see the piece there? I'll get a bigger one. Okay, so there's one there. So here's their action. And they leave the dune grass. So they literally plant this fast. And it actually scares people when they see them work. We can do if I take 5 guys there, and if we have a whole day, we can plant 50,000 plants that day. And it's unheard of, but a lot of it's technique. And now we're about a month into the planting season, and the guys aren't whining at me every day about how rotten they feel. But another key is I pay them piecework. Okay, you can't pay somebody by the hour to do that and stay happy. Actually, they'll give you new names every day. Okay, what about dune grass? Dune grass can grow in anything porous. It doesn't like clay. But other than that, concrete, I've planted it in gravel roads. There's maybe potential for even mine restoration using it. It's a transition plant. So it loves the bare soil of the bare sand, I should say, of the dune and the lakeshore situation. But at the same time, it won't grow into the water. I just had a job up north in north end of Lower Michigan. I got called in. I love the garden experts and the master gardeners in a community, but this poor person hit the panic button and told them the dune grass we planted in the park was going to grow into their lake and take it over. So without asking anyone who had a knowledge of it, they literally ripped out all the dune grass with an excavator and said, now what are we going to do? I wish they'd have talked to me first. One thing that dune grass does not like is competition. It's made to be a transition plant. So you plant it, if you leave it alone, In about 10 years, it'll start to use up all the nutrients it needs, and it'll have created a humus, and other plants will start to be able to seed themselves in. And in 20 or 30 years, if you don't touch it, you won't have dune grass anymore. Invasives like spotted knapweed, which have toxic roots, will actually kill it. I've seen it literally, in 5 years, destroy the whole field of dune grass, and all you have is spotted knapweed left. It's a dreadful, dangerous plant. One little trick with dune grass is it's very easy to keep it going, to get it to grow by simple triple 12 fertilizer or milorganite, whatever. A little bit goes a long way in dune grass, and it seems to keep it thick. And as far as controlling other plants in it, if you're trying to keep it neat and clean, a basic broadleaf doesn't harm the dune grass. You think of it as like a lawn, you can actually take the weeds out of it without any issues. You can spray broadleaf right over it. And there's lots of different varieties. 2,4-D is the basic one. One interesting little tip is Roundup glyphosate is very effective if you have invasives you're trying to get rid of that are like quackgrass, for example, which will choke out the dune grass, make it look messy. If you're in kind of a place where you're concerned about that, when dune grass is dormant in March, completely brown, oftentimes the invasive grasses are green, and you can go right over top of dune grass and not touch it. If it's brown, it can't take in the glyphosate. So it's a very simple way of cleaning it up. So let's see what's here. Oh, this is important for me to cover. Dune grass, let me give you a quick story. I've got some pictures on here too, but I didn't want to distract from what I had to say by showing you the pictures at the wrong time. Highway 2, many of you came up Highway 2, you cross Big Mac and you rode along Lake Michigan, and the first town you came to was Brevoort. Between Big Mac and Brevoort, there's dune grass all along the sides of the road. That was a terrible situation that was in negotiation for years because of protected plants that were in that area. But every year it would blow sand over the road, and they would literally have to get out loaders and clean it off every year. So it's been some years now, probably 7 to 10. But what happened was they finally came up with an agreement, and I learned a lesson in that job too, and that is I got a call from someone that said we need 50,000 dune grass planted. Give me a price. So I gave him a price, assuming things that I shouldn't have, and never heard a word back. And 4 months later, I get a call. We're ready to start. Who are you and where are you? Oh, we're in the UP. Turned out it was somebody from downstate. And I said, okay, well, you never told me any number. I just gave you a per plant price. Oh, by the way, it's through coconut fiber mat. I came unglued. I can plant through straw mat, although I prefer not to. But coconut fiber mat, this was an engineered job and overseen by a lot of plant people, will kill the dune grass. It's so dense and persistent that the dune grass will actually get killed. And so yes. Oh, 4 minutes. I thought she was waving at me. She had a question over there. Okay. So the dune grass, I had a major powwow, and I hadn't slept all night, drove all the way up to Newberry here, And we agreed that instead of any mat, they would let me plant it 6 inches apart. 6 inches will hold any sand anywhere. 6 inches is 4 per square foot. And if you noticed, and I'm going to show you some pictures here in just a second, it literally locked it down. They had to believe me. I mean, we had a major powwow. They eliminated the mat, eliminated all the cost of the mat, and at 6 inches, we just totally hit a home run. So let me show you some pictures here quickly. All right, there's some more. That's how dune grass comes. You see they pre-laid the bundles out as they're planting. We do flats that we sell for summertime planting, but the cost is obviously much higher. We've done a lot of work in sand mines, and that actually is where I get my dune grass from. I had Peter ask the question I never got to answer. He said, where do you get your dune grass from? Well, I have planted hundreds of acres of dune grass in sand mines. Dune grass loves to be thinned, and it actually stimulates it. So I just go back and thin. I have hundreds of acres I can thin from, and so it's completely sustainable. I always dig fresh, and I'm not playing around in endangered dunes. That's our dune truck, by the way, that we use to get around to different sites. This is a Sargent sand mine up in Ludington. The first one was in Muskegon. So we basically are planting different sites here. The entry. All right, I got to tell you about this, but I can tell you a lot more of a story. The short version, this is a park ranger down on Mount Baldy in Michigan City. And the reason I got his picture in here is because we were planting the site where the little boy fell down the hole in the dunes. And maybe some of you have heard that story. We actually found about 5 new holes in the dune for them. And so he followed my guys around with a radio directly to the dispatch in case we'd have gone down a hole. They were mostly 4 to 8 inches across, and obviously I wouldn't fit down a 4 to 8 inch hole. But so this is what he would do. The guys would plant the shovel, and boom, it would just be a void about 20 feet deep, and he'd put the stakes in, mark it with GPS. So it was quite something to be a part of that. So we're the last people that were actually on the dune other than park rangers. Because they closed it down after that. Hopefully they'll open it soon. If you want to know more about the story, I'd be happy to tell you, but you'll have to ask me later. This is down in Michigan City by the Yacht Basin, and this mound that you see was actually built with dune grass, and they needed us to come back and add some more to the top of it. As you can see, we work on pretty steep slopes. This was in Wisconsin. A number of the jobs Peter showed are jobs that I've done in Wisconsin. I've done a lot of work in Door County and other sites. This particular one was unique, though. It was at Maiden Rock on the Mississippi in Wisconsin. Across the river is Red Wing. And this was a sand mine that had thrown all the old spoil on the top of the cliff. And so the whole cliff was white instead of the way everybody else's cliff was like. And so they had us climb the cliff and literally plant dune grass on that site. See, they're happy. Actually, they make really good money, about triple wages once they get good at it. This is actually on Highway 2. One of the worst blowout areas, and as I said, we planted at 6 inches, so what you're seeing is 6-inch plantings right there. That's how dense it is. And the dune grass literally lifts the wind off the sand and prevents it from blowing. As I said, hands and knees. That's also Highway 2. That's Highway 2 again. Some of you would know about the Two Heart River Suspension Bridge. We planted that when that was rebuilt. That was before the lodge burned down. So we planted that whole entrance. And that's my last slide, and that was Highway 2. And that was a site that literally blew the hole into the dune there. And once we planted it, that was it. It stayed right where it was. So I hope I did pretty good on timing. Anything I may have missed there on the sheet that's handed out, that's why we did it. There's contact points. I want you to use me as a resource because I'm found through the years that I'm better off talking to engineers before they design something than after. And we avoid the coconut fiber mat thing.
So you're from Holland, Michigan.
Yes.
Right, in Holland, if you go there through the spring alongside the lakeshore, everybody has signs saying free sand, and then more free sand, and freer sand. How, does the city have any plans for putting in dune grass so you don't have to, everybody, like, it makes, it's weird, but
It is
in
weird.
the winter time, we get sand.
Yes.
But can you explain that, like, would the cities do better to get more dune grass?
In my opinion, yes. But what the main issue is, the parks there are very heavily used, and so they have, you know, football sized areas, football field sized areas that they don't want to plant dune grass because people are always playing that and laying out on the beach there. And they have tremendous winds that come through there and just stack the sand up 8 feet on the parking lots. Now, obviously, from my point of view, they ought to plant dune grass and all of that. But I've talked to people, and not only is that an issue, but then what's left is a whole lot of invasive plants that they don't seem to do any control on. So from the plant point of view, it just keeps getting worse. Yeah. It's bizarre in many ways that they just give it away.
It looks like snow.
It is literally drifted like that, yes. Yeah. It's almost, the main park there is almost a quarter mile from the water to the first sand dunes. And they let it blow out every year and then push it back, haul it away, start over again. But it's also on the north side of the Holland Pier revetment, which means that area collects the sand. And that I work on the shore all the time, and what the piers do to the flow of the sand along the shore is quite shocking. I hope that helped. I've had the same question. Yes.
So I guess you do a lot on the beach anyway, the sport dune work. Can you also plant in the back shore area, in front of the sport dune? And will that create more dune at that location?
Yeah, anywhere there's moving sand, it will create dune, yes. I oftentimes will work with homeowners. There's certain techniques you can use with snow fence combined with the dune grass that we can build 6 to 8 feet of sand a year. In addition to that, dune grass is, more and more I'm finding uses for it as an alternative landscape plant. A lot of the 60-year-old people like me are going, you know, I'm sick of pushing a lawnmower. I'm trying to reduce my carbon footprint. So we'll do a simple landscape by pushing 6 inches of sand all over their yard with a few mounds, do some birch trees, some hardy roses, a few rocks, and all dune grass. And they literally, if they don't want to do anything to their yard the rest of their life, they won't have to. if they get a little fussy, they, you know, there's ways of keeping it a little cleaner. So it's literally a fantastic low maintenance landscape too.
Thank you, Dean.
Thank you.
Our next presenter is Katie Moss-Seed, who is a community planner at the Land Information Access Association in Traverse City. The presentation is developing land use regulations to protect coastal resources in Grand Haven.
Hi everyone, how's it going? Thanks for being here on this last day of the conference. I'm Katie Moss-Seed. I'm a community planner at the Land Information Access Association, or LIAA, or LEA. We go by all three. We're based out of Traverse City, Michigan. And I'm excited to be here today to share with you a little bit about a research-based project that is currently underway in the Grand Haven community to develop land use regulations to protect coastal resources. So I'll be sharing with you a little bit of the observations and the findings so far through this study. Okay, so a little bit more about LEA. Again, we're a nonprofit corporation founded in 1993 with the mission statement to help shape better communities through participation, education, information, and the effective use of technology. And recently, since 2012, through our Planning for Resilient Communities program, we've been working on land use master plans throughout the state of Michigan in the places shown on this map that are a bit unique in that they have a focus on resiliency, which we define as climate and coastal adaptation. We'll get into a little bit more about that in a moment. The project team for this project includes Dr. Richard Norton from the University of Michigan. He's the principal investigator, as well as his research associate, Zach Grable, and Dr. Guy Meadows, who's the director of the Great Lakes Research Center out of Michigan Tech. And it's supported by a grant through Michigan CZM Coastal Zone Management Program through the University of Michigan Graham Sustainability Institute. Okay, so this team of researchers has come together to work in Grand Haven, Michigan, and we've recently completed a project called Resilient Grand Haven, which resulted in 2 land use master plans adopted by the City of Grand Haven and Grand Haven Township earlier this year in 2016. And these were unique master plans because they had 2 things. One was that they were regional. So the city and the township worked together as they completed their master plans. And the second reason they're unique is that they had a focus on coastal resources and coastal adaptation, which is pretty rare in Michigan. So out of 291 local governments in Michigan, including counties, cities, townships, villages, that directly touch a Great Lake, we know that only about 2/3 of them have any adopted master plan. And out of those communities with master plans, only about half of those master plans have any analysis at all of coastal resources. Yet we know that coastal resources in Michigan are tremendously important to our communities. We should not only plan for them, but we should zone for them as well. So the purpose of this integrated assessment project is to take planning one step further now that we've adopted master plans through the Resilient Grand Haven project in Grand Haven Township and the City of Grand Haven, to look at implementing coastal resiliency concepts that we identified in the plan through zoning and other policy amendments. So resiliency, I've used that word a lot. Let me quickly define it. The way that we talk about resiliency with our communities is planning for and responding to change. So what is changing? A helpful way to frame discussions about resiliency and adaptation. We know that water levels change. Local officials know that water levels change. What does that mean for planning and zoning coastal area management? And we know that climate change is happening, which can sometimes be a difficult conversation to have with local governments in a political system. But we have observed trends and observed data that help us understand annual precipitation, erosion risk, lake decreases in lake cover, and changes in sediment and sand movement are all important for local land use decisions that can be brought into a planning process. We also know that land use is changing, so as Michigan moves perhaps from a more manufacturing-based economy into something new, we have many local governments that are grappling with shorelands that are now open for a different type of development, from industrial to natural or recreational. So again, the ultimate goal of this project is to help local governments be equipped with the knowledge to incorporate coastal conditions and resiliency concepts into land use regulation. And there's many, many opportunities to incorporate resiliency concepts, not just in a site-specific project, but throughout the community-wide policies, from planning to zoning and more. So in the planning stages, you really have an opportunity to inventory your coastal assets, understand their uses and their conditions by bringing in baseline data and climate data. So just as in a planning process, when you look at population growth or economic indicators, it's also important to understand your coastal areas. And really, during a planning process, you have an opportunity to have a robust civic engagement effort that can really bring together the community to identify the vision for a changing shoreline, which can help strengthen policies that you enact later down the road. And planning, of course, has many different forms, but a couple examples: master plans, sub-area plans, transportation plans. All these are opportunities to integrate resiliency concepts into local government. And then as moving through to zoning, as you have a plan that forms the basis of your zoning ordinance in Michigan to implement the community's vision by shaping the way that development looks in the future. And zoning really stands as an ideal tool to adopt best management practices at a community-wide scale to address things like sensitive habitats, water quality issues, etc. And there's also, more than just planning and zoning in our local governments. And planners can work in a variety of, with a variety of tools to help bring about greater resiliency. From stormwater plans to infrastructure policy, even the way that development proposals are reviewed in local governments, there's opportunities to widen who's at the table to help create a more resilient community. And definitely not underestimating the ability of local governments to educate, to bring in experts, to really understand, to teach staff about the importance of coastal area management, bring in experts like all of you. And then to form partnerships. Between planners, health workers, emergency managers, there's really a great many actors in our communities that have a vested interest in our coastal health, and to bring all of them to the table when discussing community-wide policies is really important. So one of the issues that keeps rising to the top throughout this Grand Haven project is our case study, is new shoreline development, which has a great number of benefits for our local communities. It means you're growing. It means you have more tax revenue. It's associated with quality development, things like trails and amenities to really enliven our waterfronts. But with new development comes a number of challenges. A short list is structural and wildfire risk. So in dune areas that are maybe difficult to access, that can threaten water quality, wetlands, dune health, stormwater control and runoff in the community at large, but also in coastal areas. And then view sheds and public access. So as the shoreline continues to develop, perhaps losing some of those things that the community has grown to be accustomed to as being part of the identity of the community. So we've identified and recognized a couple barriers that local governments come up against as they work towards action. Concerns over regulatory takings, the political viability of adopting environmental protections, and then administrative challenges. So in coordination with the DEQ, the county, and the number of agencies that must work together on permitting, it can be difficult for local governments to think about adding another step or another layer. So really our task through this project is to identify policy options that might help local governments address some of these challenges. So here's just a sample of 3 that we've come up with so far. The first, implementing landscaping standards within an overlay zone of sensitive areas. So requiring a landscaping plan, requiring native vegetation or a buffer of native vegetation between water and development. 2, requiring a flexible outcome-based site plan review process for waterfront development. So many planning commissions don't want to add an extra layer of reviewing site plans for every waterfront home or every waterfront development project, but it can be a wonderful way to incorporate green infrastructure policy and encourage private property owners to really incorporate resiliency into their site plans. And lastly, evaluating setback standards. So instead of applying what might be the average, where if you're developing a new waterfront home, you get to have the average setback of your neighbors be your distance from the lake. consider using a fixed setback from the ordinary high water mark so that over time, as properties redevelop, homes aren't inching forward towards vital coastal habitat. And then just a couple observations and takeaways from this project so far. We've noticed that coastal area management really is an entire whole community conversation. Many of the problems and solutions in coastal area management are community-wide. These communities really value their coastal assets, and it's part of the identity of the community as a whole. Secondly, the momentum generated by a planning process really has provided the education and the energy needed to adopt other policy changes. So using planning as a tool to educate, to bring in a diverse public, to then carry through into policy implementation is really important. And lastly, that communities really do have a strong commitment to preserving coastal resources, but the challenge is finding the policies that are the right fit for their needs and for their comfort level. So hopefully this short overview of a planning project can help you provide or can help inform your work as you all work with government. Thank you. Any questions? Yes.
What do you find is your biggest resistance point in working with the community with this kind of plan?
I'd say misinformation and confusion about what's really possible, and just the need to, again, widen the conversation beyond an economic perspective to include everyone in the community that's invested in coastal resources.
Jean, thanks for coming. This is the missing link that we've been, so the Great Lakes Beach Association was a lot about health departments and beach scientists, but we don't own the beaches. We have authority to work on them and stuff, but we don't own them. And so this is great that you're here. So we're wondering, how do we engage more? Like, what caught your attention? What brought you here? How did you know about us? And how can we go encourage the other communities so that we can engage with them more? Like, how does
There's a lot in that question. Let me think about it.
Can you give us a little bit of, I'll say it this way, we have lots of great ideas. Wisconsin has remediated at least 60 beaches, and I'm jealous. But what our limiting factor is getting the attention of the local beach owners, because it's usually owned by a city, a township, or county, and I don't own it. All I can do is make them jealous about something that they want, but I don't even know who they are, and then it's a political roundtable that keeps going on, so by the time you get a contact, they're out of office, now you gotta get a new person.
Hired me.
Current for hire. So I guess what I'm wondering is, we've been in this for 16 years, and we've been missing it. We've been catching a few, so it's usually the problem beaches that everybody gets mad about. But how do we intentionally go and engage more? Like, where do you meet? Where are your meetings? How can we work more closely with you? Because this is great. I'm so glad you're here.
Thank you. I think a couple things. One is that there's an incentive for local governments to be involved in this work in a number of ways. One is that they really care about their environment, and so there isn't a different ideological approach, I think, to this type of work, but sometimes the gap is in information and availability of information and scientific language being easy to understand and marketable for local officials to really hold on to. But the economic opportunity for communities to have healthy beaches, to bring in tourism, to benefit from connecting, like Marquette connecting downtown to the waterfront and really taking advantage of the great number of benefits that bringing in recreation can provide, I think, is really an important sales point, if you will. But our approach in most of these projects has been to, I'd say, use climate adaptation as a framework in our approach with working with planning commissions. So when we have grant funding to work on a master plan, which is legally required in Michigan to be updated every 5 years, we bring that information in at the beginning of the process. So as we're gathering data, just as we're gathering economic indicators and social indicators, we're looking at coastal areas and then laying all of that before a public forum and a public process to identify priorities. So there's room in that planning process for all of you. And I think it's important for you all to be involved in conversations with your local governments, and sometimes it's as simple as letting your planning commissioners know what type of information is available and out there as they go through planning work. And, you know, I think organizations like GLBA, like others, are working to educate the consultant community of planning to bring about more awareness of resiliency of climate and coastal adaptation and the need for coastal health, and work that in to planning work throughout the state. So.
Does GLBA have an organizational meeting? Do you guys, like, if you're going to get ready for, can we come to your meeting? Is there potential that we would be able to present some of this information?
Yeah, sure. We'd love to talk more about a partnership. GLBA is, we provide planning services to local governments, so we function in some ways as a consulting firm, but we really are a nonprofit that's interested in, again, helping shape better communities through public participation. So it's really our focus. When we work with individual communities, it's a very transparent, open process. So resilientmichigan.org is where you can learn about our meetings and the communities we're working in right now. So. Yes.
My group, Township Neighbors Network, is an association of shore owners, private shore owners. Of course, under law, there's a sandy sidewalk along the edge of the water, and anybody can walk there. You can't restrict that.
Right.
The problem is that we're largely rural townships, and the government is largely run by the farmers. So when you talk about community, you can't say let the farmers do the master plan, and the shore owners have to live by it. First of all, they don't have a clue what's going on the shore, and secondly, there's a political dynamic. The shore owners pay 2/3 of the taxes, but largely don't vote there because they're from elsewhere. So you have to be real careful how you define community. And I've been through master planning. It was for 3 years. We were able to accomplish a lot, but it was a bitter battle every step of the way.
Yeah, no one said that this is easy work.
Yeah, no, it's very hard work.
Mm-hmm. And I think the more you can invite that conflict that exists in every community to the forefront and really address it in a public forum is the best way to handle it. So being transparent in your processes and really making sure everyone is represented at meetings is important. But it's tough, yeah.
To break some of those barriers, would it be helpful to bring some of the other success stories of what other communities have done as an example, and say the dune grass isn't going to grow out into the lake, and you know the scary things aren't going to happen? Would you see that as a benefit if somebody came in and?
If you came to my group, yeah, sure. But if you came to the political group, I would say no. There's an exception in the towns that are along Traverse Bay. You know, Traverse is the closest town to us. Of course, Traverse City owns that city. Dealing with municipalities is a little bit easier. Unfortunately, the Grand Traverse Bay Watershed Center is largely abandoning working with the city of Traverse City, even though they've had some wonderful projects there, because the political dynamic is so awful. So there is no easy answer. And my point simply is you can't get there through elected political leadership because they do not represent the interests of shore owners. Most shore owners get everything we've been talking about. I mean, I've lived on the bay for 40 years, and it's wonderful to see the science behind all this. But by direct observation, you see what happens over the years. So I think you got to go to shore owners, private shore owners, and I think that would be the way.
Yeah, I think we would agree with that in many ways, and that's been our approach recently as well, is to start working more with watershed councils, with neighborhood associations who are of course involved in planning processes, but really using them to disseminate information, to correct misinformation, and to do the work. Sure.
I just want to comment. I'm one of those city officials who is in the process of reviewing the beach. And I think a lot of times it's talking with other city departments too, not only planning commission, but really good thing about, public works departments, we know the grass. They don't always know, so it's getting their input and telling why we should do this, because they're the ones managing the beach. I work for the Park Department, and I'm the one who manages our beaches in Nashville. And so sometimes it's getting their buy-in, and then educating the public as to why this needs to be done. They understand the whole why, somewhat, but they don't really know why we have to do a redesign, or why it really matters. And then to go at the other point, we have a program such as helping with wildlife and fields, but it's called My Lake Superior Northwoods. And it works with landowners to try to protect what they have. So a similar program to that, we have maybe work coastal wide as to how do we protect our coastal things and what are the tools out there to help municipalities, private citizens protect their coastline. What can we do? It's an example of.
Thank you.
Sorry.
No, thank you. Yeah, that's great.
Our last presentation is by Dustin Ordway from the Ordway Law Firm. He is talking about riparian rights boundaries.
Good morning. Thanks for including me in this conference. It's been very enjoyable listening to the many practical and scientific presentations. I'm going to be talking about a legal issue, boundaries, property boundaries along the lake, not the issue of whether you can walk across someone else's waterfront property, but where your side boundaries are. And hopefully you'll come away from this thinking that there's something practical here, namely if people understand what rules can be argued or may apply to their boundaries, maybe they can avoid litigation. I'm always happy to help a client get to a point where they can resolve a problem without having to go to court. And interestingly, the rule I'm going to talk about after we go through some background issues with some images and so on, is something called the Massachusetts rule. And the basic idea of the Massachusetts rule, although courts don't put it this way, is to apply a mathematical concept. How do you draw a line perpendicular to a curve? Because the issue usually comes up when you have a curved shoreline. Figuring out where side boundaries are on a straight shoreline is usually pretty simple. Or if you have, as you see to the far left here, what we have here is an aerial and then a survey drawing below it of the same section of shoreline. And if you look to the far left where you have a sharply curving shoreline where each property owner's lines continue to go farther away as the water goes out, if the beach is wider, that's easy. There's no conflict there. Or on the far right, you have a long stretch of straight shore. Again, rarely a challenge. But when you get into the other curve in the middle, if the lake levels are lower and people are moving farther away from the tree line, their boundaries, however you determine where they are, will tend to get closer, and that's where you get conflict and sometimes litigation. So the best I'm going to be able to do in terms of giving you some science today is that embedded in some of these Supreme Court decisions is this scientific concept, even though they don't put it that way. They run on and on like lawyers do and describe it in a different way. So what are we talking about? Again, the side boundary. Most property owners, whether they're municipalities, businesses, or private individuals along the shoreline, have property that's delineated, and you can see the surveyor's dark straight lines. They're delineated to a place where there are surveyor's permanent markers. It's usually called the meander line or sometimes the traverse line. And the normal concept is if any of us own to that line, we own to the water, even though the water may be another 50 or 500 feet away. But the line's intended to represent the water. And the question is, from that line, from that tree line or top of the bluff, out to the shoreline, where the water's actually touching the sand, which part of that is yours? If you want to put in a dock, or you want a dredge to be able to put your shore station out in front of your property, or if you're a municipality with a water pipe, or any of these other private and business kinds of uses, you just want to sit on the beach and enjoy it or store your boat, where can you place it so that it's on your property and not your neighbor's property? And how can you have a rule, an approach to the use, the exercise of these riparian rights, where you'll be able to know year to year as the lake levels go up and down that you still are on your property and not your neighbor's. Put in a couple of examples. This is just to illustrate, as you all are well aware, of how much the lake level changes affect the shoreline change. This is two shots of the same stretch of beach at the dunes in Saugatuck. On the left, when there had been low water a number of years recently, beach grass had grown in. I don't know if Dean was there or this just happened naturally, but there was a lot of beach grass. And yet, on the right, just this last year, you can see the water had eaten way into the foredune. And I don't know if you can detect it here, but there are white pipes set up near the trees. And in the left picture, they're way up from the water, and they're relatively close to the water. Those are surveyors' marking points between lots up away from the shore. And here's just a completely different example. Much of the Great Lakes shore is rocky. This is the same place. On the right, it looks like what a nice waterfront property. You see on the left, in those low years, it's actually a very rocky waterfront property. It just illustrates with these large boulders how much the water can change. This is one of my favorite graphics, and it's similar to one that was shown earlier, which is a slightly different variation. It shows all the Great Lakes. I usually focus on Lake Michigan and Huron because that's where most of my practice is. This is about 100 years worth of water levels variation. And you can see it's cyclic, not precisely, not regularly cyclic, it's irregular. But the water levels go up and down. And so if we're going to have a solution as to legal rights along the Great Lakes, you need to have something that will work whether the water's high or low, because the water will continue to change. And you can see at the far right, in the most recent years, well, it's come up recently, there was a longer than usual period where it was below average. And it's amazing to me as a lawyer how someone can buy property and want to build on it, and the builders will work with them, and they'll get the permits, and they'll want to build or control it as if the shore is always going to be where it's been for the last 5 years. And it just doesn't work that way. And then, lo and behold, things change. In legal decisions, judges often talk about reliction and accretion. In a strictly technical sense, these are terms that relate to land being added or taken away because of changes, but they're only supposed to be permanent changes. And I'd suggest to you, and I've tried to argue to judges, I don't always get through, that there's very little reliction or accretion on the Great Lakes because the changes are up and down. Michigan enacted a statute criminalizing clearing of vegetation on beaches just a few years ago, on the theory that these were emerging wetlands as if they were emerging permanently forever. Well, lo and behold, the water's back up. The guy that had the misdemeanor finding still has that on his record, even though the place where he may have been clearing plants is probably covered with water. So I mentioned earlier the meander line. This is just a real simplified illustration. Surveyors put markers. They may be little cement posts or metal posts, something intended to be permanent in the tree line or the top of the bluff, which here would be represented by the straight lines that go from one marker to another. And the shoreline is maybe very close to that point, as it would be illustrated here between lots B and C at that corner. Or when the water level is low and the shoreline is farther out, it could be a much wider stretch of land. So you can see on this illustration, if the owners of lots B and C had a dispute, where's the line between our properties? It shouldn't be a big deal. What is it, 10 feet, 50 feet, whatever it is, it's very close. But if the line that represents the shoreline, the edge of the water, were down below where the words are, so that the stretch, the distance you go with your boats or your chairs and your glass of wine, or if you want to put in a dock, was much farther out, there'd be a much greater potential to interfere with one another if you don't agree about what angle your boundary leaves that corner of lot B and C to go to the water. So what I'm going to talk briefly about are three different approaches that can be used legally, practically, to resolve the question, where is your side boundary? Follow past use, extend upland or backlot lines. Let's see if I can go back. So the second version would be take the line between B and C and just extend it straight out. Or the third is to calculate the boundary perpendicular to the shoreline or the water's edge. which I have argued in a case I've got, and I would propose to you, is the better rule because it's more likely to guarantee access to all of the waterfront owners, no matter how high or low the lake level is. And that's really the ultimate goal. If you own to the water, you should have access to the water. So the first approach, relying on past use, it's very common for owners to simply try to work it out. They may have a dispute, you put your chair on my beach or something like that. And the concept is if it just works, great, keep using it. You don't need lawyers, you don't need to go to court, you don't need a ruling. And there are doctrines that if someone has got a dispute with a neighbor, they can relate back to and say, because of my past use, I have this particular kind of right that is now permanent. This is now my property. At least it's now property I have a right to use, even though you, my neighbor, think it's your property. Some of the problems with it can be is that when I sell my property, my buyer may disagree with you, even though I agreed with you. There can be problems that require you then to a court to ask, well, what was said in the past? What happened for the last 15 or 20 years? Those are not necessarily easy problems to solve in court. So here's a very simple example, a view from a house on the beach down to a shore station. The right photo is the same shore station looking back at the house. Seems very simple, seems like it's on his property. But if you just turn to the right, I don't know if you can even see it, but the neighbor's house is directly back there and his yellow boat is behind the shore station. From his perspective, the shore station's right in front of his house. Now, those people are not fighting about it. They seem to be getting along. Here's another simple illustration. Again, a low, not a dune area, but a tree line with two houses in it. The one is very visible. The one on the right is sort of hidden in the trees. And there's a line of rocks that they probably spent hours enjoying summer afternoons putting the rocks out to demarcate between my property and yours. Well, when those rocks were first put out, they weren't there. They were quite a few degrees over to the right. Obviously, the neighbors talked. They worked it out. They agreed to move the rocks. It's settled until somebody sells a parcel and they say, wait a minute, I don't think that's where the rocks belong. But if you can resolve it with your use, great. Just keep in mind that you may have to use the history of that past use at some point if you do end up with a dispute. The second general approach is to extend the outline lines. The illustration on the right is a portion of the earlier illustration. This has the benefit of simplicity. You just look at your plat, you look at your parcel, you follow your lines to the tree line, and you just keep going straight with them. And it's been argued in court that this is the way to do it. It's the correct way to do it. I even had a case go to the Court of Appeals in Michigan where the court criticized a platter, an owner of property who then created separate lots, for not making all the lines parallel, because by not being parallel, they had the potential to conflict. In other words, assuming that they would continue beyond the meander line. The Bookaloo case, I'm not giving you a cite to it, but I'll just describe it briefly. This is a case where the trial court said, no, you don't do that. When you get to the top of the dune, you look straight to the water, and that's how you divide property from dune top to lake. It's a case that went to court when the Sleeping Bear National Seashore Park was first being created with condemnation. And it was a litigation between two neighboring owners over who was going to get paid more. And the main question was, who owns more of the beach? And when it went up to the Court of Appeals, they said to the trial court judge, you're wrong. We're just going to extend the back property line straight out. Where it gets to the dune, just keep going. That's the boundary. Wasn't necessarily problematic. All that was at stake was money. These were large parcels, no homes, no issue of anyone actually being out there using the beach. No one was going to say, but that's where I always kept my Hobie, or that's where my kids played in the sand. It was just about money. And the problem is you can have conflicts. As you can see on the illustration on the bottom, if you're extending back lot lines, I don't know if it's too light, but the back lot lines down to the left, because of the nature of the curve, all go apart. So the lower the water, the easier it is. Everybody gets more beach. And then on the inside curve, it's the opposite. The lower the water, everybody gets less beach. So the challenge with using back lot lines is it can tend to lead to conflict. And there are other kinds of conflict. I mean, lawyers are very good at coming up with arguments. I mean, another argument I've heard in relation to the same type of issue is, well, you may have a section line over there, but our plat was created 5 years before yours. So when our prior owner created our plat and assigned these lines, which we think should all extend all the way to the water, that took precedence. And then when your plat creator broke their parcel into individual lots, that had to be subject to what we did before, first in time sort of argument. So there are all kinds of ways to argue it. And again, it may cause you to have to look back at the history if you want to extend the back lot lines. So here's the third approach. I think of it as the common sense approach simply because in the experience of most people, I think however you go through a parcel to the top of the bluff or a tree line, the normal experience would be when someone asks you, or you're thinking, well, where's my beach, or where can I carry my chair to, or if I want to put stairs down the dune, where can I put them and stay on my property, you look straight to the water. Or to look at it from a zoning perspective, a municipal planning perspective, if you want to build there, you're going to be told you need to have a certain setback. Well, if you're extending your backlot lines to the side, is the municipality saying you need to be 60 or 80 or 100 feet back at an angle? No, they're going to say directly from the water how far back you need to be from the ordinary high water mark. So the benefit of this approach, from my perspective, is it seems to match common sense. The method has the benefit that one of us could look at a plat and draw lines now, and someone else could do it the next day or the next year. It's replicable. It's not dependent on history, recollection, where did you used to use the beach, or where the platter put the lines. The illustration on the right is actually from a litigation where the trial judge said he was going to follow the two Michigan Supreme Court decisions that are referred to below, Blodgett and Stewart. And what that court said was, when you have a cove or a bay or a curved shoreline, find two endpoints. You can see that the various lines out to the water have an ending. You draw a straight line across, you draw a line along the meander line, you compare the distance. The curved or segmented line is longer. So you compare the differences and you find the correspondingly shorter segments of the straight line out across the water. And then you draw lines that essentially are an attempt, going back to science, to try to hit a perpendicular to the curve of the shore. So the challenge with this, or one of the cons, one of the negatives, is if you own those lots on the right, this is actually from the same figure that's shown there, it's different perspective. If you think that as you go through your lot, I think you can even see lots 1, 2, 3, 4, 5, and you get to the tree line of lot 1, and if you think you're supposed to keep going in that direction, suddenly you're being required to make a sharp turn. Now you have just as much beach, maybe even a wider beach, and it seems natural because you're looking straight to the water, but it may seem wrong to you if you're that property owner because it's not continuing in the same direction you wanted it to go. So Blodgett and Stewart are 100 years old. In those two Michigan Supreme Court decisions, the court adopted what it referred to as the Massachusetts rule because it was following common law that the Massachusetts Supreme Court had set forth in cases, and that related back to the common law in Great Britain. For all I know, Ontario and other Canadian provinces may have a similar rule of law. Most coastal states in the United States have some version of the Massachusetts rule. It's not just been adopted or applied in Michigan. Florida to New England, state of Washington, Minnesota to New York, whether it's the Great Lakes or the oceans, there's the same issue. If someone owns to the high tide level in Massachusetts and at low tide they still want to be able to access a boat, even though the shoreline may be very curved, these lines of cases, although they come out in different ways and they express it in different ways, the common theme tends to be if you own to the waterfront, you own to the water. You have rights of access to the water. And if you come to court and you're asking a court to resolve your situation, you should be able to get a ruling that confirms your boundaries work in such a way that you will have access to the water. It's a basic enough concept that in this very case, I think it's labeled the park, private park. That's a jointly owned parcel that's next to what's Lot 1. Lot 1's even argued, well, it looks like it's platted to the meander line. It looks like it ought to be waterfront, but it's not even riparian. And in fact, in this case, they convinced the Court of Appeals to remand the case back to the trial court to hold a trial about whether that parcel was riparian, because I guess the theory is if it's, even though it's drawn to that place at the lakeshore, if it's not riparian, then it's okay for someone else to have that beach. So I don't know if you want them. I'm assuming everyone after today will have access to these. So if you want to look up these cases, the citations are there. I know you don't need to write them down now, but they're in there. And in summary, the concept that I'm trying to describe these possible different approaches is to deal with the issue that the lakes do go up and down. They're constantly changing. We need something. Hopefully, if you have a decision in court or you work out something with your neighbor or a municipality says, you're here, we're there, those rulings, those decisions are good next year and in 15 years, not just this year. Part of the concepts are, as I said, to ensure access, and also that once you get out to wherever the water is, whether it's low tide or at Lake Michigan or the other Great Lakes at low water in those years, hopefully you're going to have approximately proportional access out there. If you have 100 feet at the meander line, maybe it's only going to be 50 feet each out there, but hopefully it won't be your neighbor having 85 feet and you're having 35. Thank you. Any questions? I know we're not done, but yeah, go ahead.
So the idea of drawing the complex shoreline. So shorelines are pretty dynamic. When you have after a major storm, does that have to redraw the property lines?
Right, and I think what a surveyor trying to help you with that would do is they will commonly.
Can you go out in front and talk to her?
They'll commonly show on an illustration if you need them to on a survey exactly where on that day the shoreline was, but they can also draw an approximation. In other words, if you have a curved section of shore, it may, as you're saying, change day to day or week to week. But in the perpendicular approach is clearly an approximation. It's not something that's always going to be precisely the same. And you may have something that feels like reduction and accretion where maybe not only for a week, but for a couple of years, there's more sand over here or over there. So it's not perfection. If you can make sure that each owner, each neighbor has access, you've done a good job. Is that enough? Other questions?
I'm wondering how well we can using Massachusetts and other ocean community methods to determine how to apply to Great Lakes. Is it radically different? We have daily tides changing versus the Great Lakes.
Yeah, there's certainly not a lot of difference. The question is whether in Massachusetts or other oceanfront jurisdictions, it's a different problem than on the Great Lakes. I think, to me, the simple answer is it's not really different. There's certainly very different practical day-to-day differences because, as you say, the tides are going in and out. But in the end, the question is access. The question is if you own to the high tide level in Massachusetts or you own to the top of the bluff or to the tree line in Michigan or other Great Lakes states, what is your ownership interest in right? How can you use your property from there out to and out onto the water? Yeah. Other questions? Thank you.
one thing. I'm lucky. I'm sitting next to Raj and Callum, and we were talking kind of briefly. So we were kind of going back to talk about how Americans do things, and then how Canada has a different approach to the city insurance. So we have a second, so you can explain Canada how it's found with the property.
Yeah, in
You guys go there, and you can tell me what they want.
So before they can say anything, I'm going to say I believe Canada is a common law jurisdiction that goes back in some respects to the British system as well.
Yes, yeah.
Tell us how
I can't speak like you, but in lawyer's language. But as far as I know, the shoreline property, anything touched by water is owned by government. So we call crown property. So property owners can use the beach and have ownership or rent for $1 for 99 years or something. That is how, but it's for everybody's use.
Right.
So it's not like people don't own the water property.
Yeah. Well, let me respond to that because I don't think I disagree and it didn't mean to apply otherwise. In Michigan, if you're inland, you have an inland lake and stream, and you own property along a stream or an inland lake, not a great lake. You own the land under the stream, to the center of the lake, the thread of the river, and that's a whole interesting other story. At the Great Lakes, on the Great Lakes in Michigan, I think it's true with any jurisdiction, the state owns the land under the lake. So if you live on Lake Michigan or other Great Lakes, you don't own the bottom of the lake. And in fact, in addition to that, the state has an interest, a public trust interest, not only under the water, but up to the ordinary high water mark, which can be well above the water. So I think in that sense, we're comparable. And that's where the Glass v. Gecko case comes from. It says people who don't live along the shore at all still have the right to walk the shore because there's a public trust interest at the edge. Now, in Michigan and any Great Lakes state, you can put a dock out, maybe even a permanent dock, if you can get permission from the U.S. Army Corps of Engineers. I don't know if in Canada that's possible, but you might have to get that 99-year lease.
Yeah, in the UK, it's very similar to what Raj, I mean, obviously coastal water, everything below the high water line is owned by the state or the Crown, whatever she calls herself. But then the dry beachfront, most of the UK, the beachfronts would be owned by the local councils. But there are locations, so the castle I showed, Culzean Castle, that beach is actually owned by the estate of the castle, so it's a private beach, but it goes with the boundary of the whole estate. So we very rarely have a coastal property by property by property situation. And some inland places it tends to be the property, and it's all defined depending on the full extent of the area that they're looking after, whether it's a caravan park, they don't the extent from A to B. They wouldn't have close by close issues about lines perpendicular. I don't like that solution, sounds very sensible.
Yeah, it's nice to be able to avoid it, although everyone who owns property along the Great Lakes privately would not want to lose it.
Yeah.
But it's somewhat similar to a different issue. Other cases I deal with development of sand dunes, which is development up from the water. It's not an issue of down on the beach as we've been discussing. And that's where the state of Michigan requires a balance between the private right to develop and use it yourself and the public interest in preserving certain qualities of the dunes. And it's another whole issue. And it may be in other parts of the world, there are already protections in place for that sort of thing. It's still a developing issue. Thank you.
That concludes our webinar. Thank you for participating via the webinar. That's the closing of the conference. Thank you.
All right, so we have one last thing for you to listen to. We have Jerry Mills back. He's going to give us a song before we leave to say goodbye.